Wow, Neil Armstrong. Hey, wait a minute. You're supposed to be on the moon. I just saw it on TV.
Oh, there's a tape delay and with all solar winds.
Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
You don't see the curvature of the Earth. That stuff is flat.
Globebuster's taking over. Bye-bye, moon man and rover. NASA's so mediocre. Sorry, but your ball is dead, but your ball is. Globebuster's taking over. Gotta ride this roller coaster, but the truth is getting closer. Sorry, but your ball is dead, but your ball is. Get the shovel for the space hubble, piecing up the puzzle. Need to burst your bubble, evil gonna crumble, yeah? Sit down and be humble, got the ball, you better fumble. You'll get mad, cause at this fight I'm about your uncle.
And then they call me the liar. I mean, it's absolutely unbelievable the pathetic techniques that they have to use to prove their heliocentric model.
Vibes at the president, Jeran got the evidence. Aerosland, Jesuits, and Zack is evident. That the earth electric and it's resonant. Your residence is heavens, and I hope to settle in like some sediment. If we so wrong, why they lying to discredit it? That's not too intelligent. That's a guy, not an in court, but we ain't really in the settlement. It's time to awaken from the pseudoscience sedatives.
Globebuster's taking over. Bye-bye, moon man and rover. NASA's so mediocre. Sorry, but your ball is dead, but your ball is. Globebuster's taking over. Gotta ride this roller coaster, but the truth is getting closer. Sorry, but your ball is dead, but your ball is.
Inner World Productions.
We accept the reality of the world with which we're presented. It's as simple as that.
And welcome everybody to Globebusters, NASA's Fairyland Physics. Yes, Fairyland Physics. I debated on whether or not to call it Narnia, but Fairyland is, it's about the same thing, I'm thinking. So that's what we named it, and I think it's quite appropriate, considering that, NASA is the one that sets their own rules. They set the curriculum, and then they break their own rules. And it's amazing the mind control techniques that they use to get people to accept it, all the way from, primary school children all the way up to college graduates getting their PhDs. And in fact, as we have pointed out many, many times before, it seems like, well, there's no seems about it, it's a definite fact. The higher you go in the education system, the higher the probability is that you will be completely taken in by the lie, and you will buy into it completely. You've got everything, at risk when you don't buy into it. And if you do buy into it, well, then you're going to be okay. And most people don't want to lose their means of support or anything like that. And I can certainly understand that. But if you honestly have an open mind, as we and most flat earthers do, we can see the blatant problems. I mean, come on, guys. I've said a million times, we have all the evidence. The ball earthers have no evidence whatsoever. The sphere Earth, there is no evidence for the sphere Earth. It either works on a flat Earth, a ball Earth, or both. And, there really isn't anything that works on the ball Earth. I think we pretty much debunked all that. And all you have to do is just put down your doubting and your willingness to believe NASA and, the government, and that they are trying to do everything for our own good. And you will find that we live in a world of lies. Of course, these days, it's not hard to tell that, right? We are we are acutely aware of what's going on in so many ways. And every single day it gets more and more and more crazy. And, the people that are awake, it's amazing. We're running around saying conspiracy, conspiracy. And we know that it's a conspiracy and we know what they're doing and we can see it clearly. And yet we can also see the very well thought out chess game to turn everything around 180 degrees, inside out, backwards, upside down, using the satanic method that they use. And it is quite an effective tool in, kind of staving off the truth that we try and bring forward. So that's why we do this show, guys. And that's why, I'm not going to stop until, something changes. And admit, we have small victories here and there, but honestly, the way that the world is going these days, I'm dumbfounded, especially all the things that are going on in some of the certain states like Portland or Oregon. And oh my God, it's insane. But we all know about that. But yeah, whatever. So we are here to talk about Flat Earth today, and we are here to talk about NASA and their Fairyland physics. And we also are here to talk about a brand new Globebuster that we have added to the panel. You guys may have noticed we've kind of been a little sparse on the shows, but we have had some personnel problems. Either certain people couldn't make it at certain times, or, it was just kind of like herding cats, getting everybody in the same place. So what I decided to do would be to kind of change around our panel members and invite in some of the, really good talents that are in the Flat Earth community, that are specifically science minded, and highlight their work on Globebusters, because that's kind of what we want to be known for, is the science of this. And so we have decided to to bring in a brand new Globebuster. I don't know if indoctrinate's a good word. That's probably not a good word, but we have inducted a new Globebuster. There you go. And his name is Mr. Kyle Adams. And Kyle, we're really happy to have you here with us, buddy. How you doing?
I'm doing great. Thank you for all the kind words.
Okay. And yeah, indoctrinate, wrong word. Sorry about that.
You're fine.
Sometimes I get it wrong, but I just kind of go off and say whatever pops into my head. So
I get it.
It's pretty funny. So yeah, the reason the reason that I picked Kyle's stuff is he has he's definitely gone to the scientific type of stuff, and he has called his channel basically the Flat Earth Institute of Science. Put your world to the test. He has discussion boards that people are invited to go and debate there. And I must say, Kyle, that, when I look at what you're doing there, it's absolutely brilliant in the way that you handle these people. And again, you have a patience that I don't have, because most of these people are there, and why they're there. They're there, to purposely discredit you and everything that you do. So I have to take my hat off to you, buddy, because you do something that is amazing. It's very definitely needed. And you have the type of thinking and logical deductive capabilities to really drive these points home. And that's one of the reasons why I was really excited to get you on the panel. And so, yeah. So
I remember as a kid, I was one of those kids who would talk to the telemarketers for 4 hours, just trying to get different information out of them that they're not supposed to give you. Oh, really? What's your home phone number? Oh, I don't really want to give you my home phone number. Well, you've got my home phone number. You're talking to me. Why can't I have your home phone number? And so I would talk to them for 4 hours straight to try and get all the information out of them that they're not supposed to give me. And, oh, wow, you've got a pretty name. And so just kind of, where do you live? And so just kind of trying to fish that out of them. And it was just super entertaining for me. And so if these people are paid trolls that come over here to try and argue with me about anything, what the most I really want to do is try and establish common ground with them. And that way I can get them to agree with me on even the smallest of little things. And when that happens, I think progress can be made.
Yeah. Well, assuming they are not in this specifically to, derail things. And so many of the people that you are dealing with are in debt to do just that, like Bob the Science Guy. Not too sure about, what's that guy's name? Oh, crud.
Mr. Sensible,
Mr.
he's the one I'm
Sensible.
always talking to.
Yeah, I'm
Yeah.
not so sure about him, but that whole mage thing kind of is like, why would you name your project after a magician type of thing? I mean, that is Illuminati through and through. That is just insane
Yeah.
that
I
they would do
I,
that.
I gave I teased him a lot about that.
Yeah, well, he should be, and it's the same thing with,
Yeah.
people like Slice Barkane. I gave him crap about that. It's like, really? You sit there and you talk about us being deceitful, and you actually have the gall to openly call yourself Sly Sparkane. And then I brought up the definition of sly, I mean, same difference.
Yeah, he's like trying to say, oh well, a mage in this instance is just a wise man or a wise person. I was like, I'm sorry, calling it mage, you just can't think about it in America. I don't know if it's a British thing or something, but in America, you just think of magician. And so I don't know. It just sounds like you're trying to pull someone's leg. It's kind of like a ha ha kind of an inside joke or something like that. But that's kind of typical of NASA. So
Yeah, they like to stick it right in front of your face and just shake it there. It's like, ha ha ha, here it is. And,
yeah.
of all people that they should be doing this to, it should not be the flat earthers. It's like, shit, we're crazy enough doing it to each other when it isn't even warranted. So if they think that they can get away with it, when we're expecting it from them, I don't think so. But
Yeah, it's all about building that relationship of trust. And when you just kind of name it mage, it doesn't sound the least bit trustworthy.
yep, that's true. And then there are other people that, that may be on the level that I've talked to some of them, but I think again, they probably figured that if they were to come over and acknowledge any one of these major points that we have, and most of them are absolutely death blows to the heliocentric model, then they're going to have to face looking at an entirely different paradigm and the possibility that, hey, you know what? Maybe we do live in a world full of liars, and maybe it is possible that these people are in this not for our own good, but for their own good. And, they're just part of the deception. And, I got to tell you, that's a pretty scary thought, because when I first went through that years and years and years ago, this is long before I was a flat earther, and I was looking at things like, what was the guy's name? Da, 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 da. Oh,
Jordan Maxwell, Lee Cooper.
yeah. I'm trying to remember, Fred, the deeper insights into the Illuminati formula. That was a book by
Springmaster.
Fritz Springmeier.
Yeah, that one.
I mean, I read that book and I put that thing down and I was just speechless, because I knew 100% that everything that person said was true. And I don't know how I knew that. Well, I think it was a combination of so many other things that I had done before, but it was literally bone chilling. It's like, oh my God. And then you kind of get this sense of hopelessness. It's like, what can we possibly do? Or, we've got all the odds stacked against us, and, you go into this depressing type of stage, and, everybody handles it differently, I think. But I think ultimately everybody also comes out of it with the, feeling a little more liberated, knowing that we are seeing the truth, and, being the type of people that we are, we really do want to help a lot of these people out of this blindfold that they've put over our eyes,
Absolutely.
So
I was just talking with a guy last night. He's like, you got to really be careful about this stuff, because I know a guy who the FBI went after him and kind of framed him for all the stuff that he never did. And yeah, they got him. Now he's been sentenced for 10 years. I'm like, yeah, I've got too much of a warrior spirit to just kind of sit on my hands and not do anything or say anything.
yeah, I mean, and there, make no doubt about it, there are other white hats out there. There are people behind the scenes that are working, as hard as we are to, make things go the other way. And we just have to kind of stick to that and understand that they can't necessarily go public about a lot of things. But the good news is we're seeing it creep into the mainstream more and more and more. And thank goodness for that, because otherwise you could get really bummed out, trying to deal with this. So,
Yeah.
so all right. So let's move on and get to the other panel members. We have with us today Zach, Zachary Zabala, or Good Times for All if you prefer. How you doing today, Zach?
Hey, Bob, doing good, doing good. I already had a really good early day, so yeah, got me a little nap in, so I'm ready to go.
Awesome. Yes, we have a video we get to world premiere of yours today, don't we?
Yeah, I realized that in the first incoherent electrostatic acceleration video we did, I didn't really touch on the topic of the acceleration, which is a huge, that's like the nail to me, like a nail in the coffin. That's the one that really sets the difference in the bias. And I totally overlooked it. So I apologize to everybody. Yeah, just, I was already too deep into that thing at the time. But yeah, it just dawned on me, hey, we didn't cover it. So I went ahead and made an acceleration part to it and brought up a couple old things that a lot of people seem to overlook. I still see a lot of talking about the word gravity, having it to apply here on Earth. And even in their model, that does not happen. It doesn't work that way.
Yeah.
Gravity is about the lights in the sky. That's the one thing I wish people would get. When they talk gravity, Newtonian or Einsteinian, they're talking about the lights above and how they orbit, how the moon orbits the Earth, or we orbit the sun. The sun orbits through the Milky Way. That's what gravity is doing. Nothing to do with a rock falling here on Earth.
Yeah, exactly. Well, that was basically the whole purpose. And hopefully, guys, my audio is a little bit louder. I noticed somebody said that my audio was a little low, so I cranked it up a bit. So let me know if that sounds better, guys. And yeah, you're right. I mean, they invented, well, I should say they hijacked the word gravity, which, basically means weight or gravitas, right? And they put it, they made it this fictitious force that is fictitiously derived from supposedly mass attracting mass initially, and then Einstein comes around and says, "Oh no, it's really more space-time being bendy space-time." And of course, if you modify space, then you have to modify time. And the ridiculous part of that is we have no way of detecting any space modifications as far as size. I mean, how do you detect a change in nothing, right? And emptiness. How do you detect a change in a concept? So, like time, time is, we can have all kinds of things that we can base time on. In fact, it's based on the decay rate of a cesium atom, right? Where it has a specific decay, a nuclear decay. And we say, okay, well, there's that point, and that we're going to call that 1 second, right? So that's what we're calling time is. But other than that, all we have for that is clocks. And when they tell us really stupid stuff, like, if you have one guy that's on a spaceship and he travels away, you hang two identical clocks around their necks, like one guy's staying here and one guy's staying there, and one guy flies away into space and then comes back, that the time constant will have changed, and one will have aged and one won't have, right? Well, that's really stupid, because then their own relativity theory kind of debunks that idea, because so which one are you taking it from? The relativity, the guy that actually traveled away from the guy that stayed here on Earth, or do you take it from the perspective of the guy that watched the guy go away and stayed here on Earth, right? What's the difference? Six one way, half a dozen the other, and yet we're supposed to believe that time and space are going to change for one of them only. And again, it debunks itself. So many people are understanding that Einstein theories of relativity are bunk. They're utterly ridiculous. And like I said, they give us these things like LIGO, and they are telling us that they can actually detect space-time variances, right? Well, no, that's not what LIGO does. LIGO is nothing more than a laser interferometer. And the ironic part about it, it is based on the absolute existence of the ether. Without the ether, it could never work, because under relativity, everything would be, all things considered equal, everything would be the same, and you would never get any differences in speed no matter what. So before they did that, they came out with the idea of the Lorentz contraction, saying that, well, they were sampling in the device, they were sampling the wind, the ether wind, was actually shortening up, and it was then canceling out the effects of the space-time continuum, which again is utterly ridiculous. Again, there's no such thing as a graviton. There is no such thing as a gravimetric field, and there is certainly no proof whatsoever that any gravitational field or wave that is coming towards Earth or passing through any of these interferometers is causing things to shorten up by, get this, 1/1000th the width of a proton. And I'm not even sure a laser interferometer with all its accuracy is even capable of detecting that level of accuracy. One thing I do know, and I'll tell you this, is that the Michelson-Morley type of interferometer, and I've told this story before, we had a calibration expert in FE Core that joined FE Core about 6 months before I left Denver. And his business was to take high precision instruments, and they manufactured them, they created them, they calibrated them, and all this fun stuff. It was great. So he invited me to his shop one day, and it was so cool because he had a Michelson-Morley device that was sitting there that they actually did these, calibrations on a lot of these high precision instruments. And we're sitting there, and he fires it up, and we're sitting there watching it. And I'm looking at him like, why is it going down? Why does it appear to be going down in size? And he goes, well, because it was a Friday night on a weekend, and it was in the wintertime, and we had just come back in there, but they had turned down the heat, right? So this Michelson-Morley interferometer was actually detecting the shrinkage of the steel and wood plates, right, that they used, to measure this stuff. It was actually detecting that shrinking because of the change of heat in the lab. And that just blew my mind. I'm just like, you got to be kidding me. And so that's the level of sensitivity that these things have. But, again, yeah, we get that because we know that when things contract, when things get cold, things contract, right? But, NASA would like to throw in these Narnian physics and say, well, when space-time or phenomena crosses them, they also contract, which is nonsense. And they have no proof of that ever whatsoever, and they never will. And this is one of these things that they just expect everybody to believe. And I'm sorry, but I don't think so, Tim.
But beside that, it's the same thing with the Cavendish experiment. I mean, if you don't be able to take out all the external factor, especially the temperature, if you cannot cool down the complete room to absolute zero almost to do that type of experiment, you are always you can be betrayed by those dynamics produced by temperature on the air itself and things like that.
Yes, absolutely. That's absolutely correct. So
you got to think about ground vibrations in there as well. You just think about a seismometer and how they take a pendulum and they track the vibration in the ground with the pendulum. It's going to shake it. So how is the Earth moving, or the ground vibrations there? How is that affecting the results on the Cavendish experiment?
Yeah, exactly. Well, even the LIGO experiments, because LIGO, and this blew me away, right? So if they're actually claiming to be able to detect a width change or a length change of 1/1000th the width of a proton, which is complete BS, in my opinion, then, they're basically saying that this platform has to be so unbelievably stable that, well, there would be nothing like it, right? Well, we know nothing could
Is
possibly
it
be that stable.
perfectly? Yeah, is it perfectly proton flat? Like that lens is like atom to atom perfect? I mean, come on, it's ridiculous when they say stuff like that. A proton, they can't
Yeah.
even see a proton, but yet they're saying something that's a fraction of a proton.
Right.
That's ludicrous.
Well, and they're saying, well, that's the reason for the redundant sites of the LIGO site. They have two sites. Well, they actually have multiple sites, and they're saying that when both of them get this change in length, then they've got a positive hit for a gravitational change. But it's so funny because LIGO, the one in Livingston, Louisiana, I believe, is built like right on the intersection of three fault lines. I was like, oh yeah, that's going to be a real good place to put something like that. Unbelievable. So yeah, just nonsense. And they debunk themselves. That's the amazing thing about it. So, I don't know what to say about that. It's kind of weird though. So anyway,
Let's just put this where it can get the most amount of interference as possible and see if no one notices.
Yeah, and then make up these Narnia rules that nobody else can go out into space or check or even prove to us here on Earth, right? Can't be done. We can't even detect the motion of the Earth, even with something that is allegedly able to detect the 1/1000th, the width of a proton, right? Change. We can't detect the multiple different motions of the Earth. Leading up to, millions of miles an hour, no way. So, and of course, this is all NASA brought to you, and, NASA can't prove it. And anybody that actually goes to school and gets indoctrinated to the level of PhD, well, they're either dumb as hell, or they're willfully ignorant, or they just don't want to lose their income, which I think is a lot of it too. But I also think a lot of them are willfully ignorant. And it's just crazy.
What happened with the gyroscope made by Foucault, the wood one, the one made on wood, for example, because science still use that argument that the gyroscope from Foucault detect the rotation of the Earth. And I mean, we have now way better technology than that. We have more precision gyroscope, and mechanically speaking. And you are not able to detect that. So they contradict, based on the argument that they need to push into the agenda.
Yep, absolutely.
Oh, yeah, and the agenda they're pushing is 100% a lie. I just saw some evidence of this the other day. I was looking at August Picard stuff, trying to find the date he went up in the balloon. And I just went to Wiki real quick. Not real research, it was the first one that popped up. But I figured they'd give me the date, and that's all I was looking for. So I'm looking through it, and I read this one part, and it said they were considered the first human beings to ever see the curvature of the Earth. When out of the guy's mouth said it was a flat disc with upturned edges.
Yeah.
But, yeah, in Wiki right now, it says that they're the first people supposedly to see the curve, get high enough to see the curve of the Earth.
Yeah.
50-something thousand feet. Yeah, it was hilarious.
Nonsense. So we have a comment in the chat from Dr. Bass Ackwards who says, the heliocentric model doesn't work anyways. Ever heard of the three-body problem? Oh, yeah. That's one of the biggest jokes out there. They can sit there and they can mathematically describe orbital mechanics for two bodies and two bodies only. But as soon as you add that third body in there, there is no equation, no supercomputer powerful enough to be able to predict the motions of that third body, because the variables become way too complex, right? But NASA will sit there and tell you that they can put, umpteen gajillion satellites in orbit that are all affecting each other, all being affected by every body in the solar system, the Earth, the moon, the sun, the other planets, God knows what else we're going through. And so how do they deal with it? Well, they just ignore it. Just ignore it. And
then it's where it comes things important for them, like satellite, because when you bring this topic to the science community, immediately they're going to shoot you the idea of, okay, it doesn't matter the three-body problem because our satellites works and are in orbit and things like that, you know. And then that is why they need to keep pushing this story, this Narnia thing, with a lot of quote unquote weight based on magical equipment, where nobody can go and check, of course, but there is this idea in the community that we have things work on the Newtonian principles, you know, like satellites, not based on Einsteinian's principles, for example, because nobody calculates the space-time, the bending of space-time to put a satellite in orbit, supposedly. But they use all these things to trying to, you know, make people look other way.
Yes, absolutely. So yeah, you know, how do you deal with it? Well, you deal with it by, you know, calling it out at every instance. And, you know, one of the other things that I'm going to point out today, we're going to cover Kyle's, you know, really good question that he asked in his most recent video about the ISS. But one of the other things that I'm going to point out again about the ISS, and something that we have questioned many, many times before, is how is it that with the ISS going around the Earth at, you know, 17,500 miles per hour or 5 miles per second, how is it that they are able to keep the bottom of the ISS, or where the cupola is, always facing towards the Earth without exhausting a huge amount of fuel? Well, the mainstream tells us that they have these gyro type of correctors. But if you think about that, guys, that's just stupid. Because the mass of the ISS, first of all, those gyro correctors would have to generate more of an inertial force to overcome that inertia that's being generated by the ISS going around, right? In other words, something's got to force the belly of that ISS over and keep it towards the ground all the time, right? And that's not happening.
These teeny little arms around and try and get this thing to spin around.
It's absurd. And they're not using any fuel or any propulsion to do this. The only thing they do that for is they have these occasional, you know, altitude correction rocket fires, right? But literally, if you think about it, in order to keep that thing twisting over all the time, to keep it facing down one side all the time, it's impossible. And if you don't do that, then when the ISS is falling down, as in it falls down to one side of the Earth, and then it would have to actually start going backwards, right? So then we're starting to look at a 34 or 35,000 mile an hour change in velocity in, you know, over a 12-hour, or not even a 12-hour, was it do it every 90 minutes, every 45 minutes? That's absurd. Absolutely absurd. How do they deal with it? Well, let's just not talk about it, right? And we'll come up with some nonsense that tells people, oh, we've got these gyro corrector things, and yeah, that's what's going to keep the belly of the ISS down. Absolute horse manure.
A wizard did it, right?
A wizard did it. Yes. So, Kyle, what I want to do. Oh, go ahead, Hero.
No, I mean, well said. You know, a wizard did it. Yeah, a Jesuit did it.
A Jesuit did it. Yeah, for sure. Yeah, and let's not forget, you know, it was a Jesuit that came up with the Big Bang Theory and all the other nonsense that.
No. Let me just correct, because the first guy who bring the idea of everything came from a primordial type of atom was Edgar Allan Poe in his book called Eureka.
Oh, that's
and
right.
That book was read by Georges Lamaitre, and then Georges Lamaitre bring from Narnia, quote unquote, the idea of the Big Bang.
Yep.
So Jesuits are really good to, you know, invent things, but they are better to steal things, you know.
And it makes you how many people wonder, you know, if they even wonder at all about a religious person, a man of religion, you know, coming up with the most defining, you know, event in all of history, right? The Big Bang.
Their religion is the sun worship, so it match in that sense.
Yeah, and not only that,
heliocentric model is a religion.
Exactly, and it's completely against the story that's told in Genesis. I mean, it talks about an event that happens in a billionth of a millionth of a trillionth of a second, or nothing went to everything. And in the biblical account, not only of the standard Bible, but many other cultures and many other religious texts, tells us that it was created, spoken into existence, whatnot. Which again, this deals very much with what we're talking about with the ether, and they are at such stark contrast. It's unbelievable, and it's no wonder everybody's confused about it. But so anyway, so
I think they're getting ready to change the name of the heliocentric system. Something's telling me, because I don't think it's really the sun they worship. I think it's the black hole at the center of our galaxy. Did you see that? They supposedly got a picture of the black hole of the Milky Way.
Oh yeah, so many times now.
When are we going to change it to the black centric system or whatever it's going to be?
That will be nice.
Yeah, we're not going around the sun anymore. We're going around a black hole along with the sun.
Well, bad news for you, not for you, but for the science community, because yesterday I read an article telling us that the Big Bang expansion, it's starting to contract now. We are not expanding anymore.
Oh, really? Oh.
Yeah.
Wow.
Yeah.
So
very bad for the guys who are on the edge, and now they start losing the edge of the universe. They are not going to came back to our universe anymore. They've been lost on the edge of the universe.
Mm-hmm. Excellent. Okay, so guys, what I want to start out with is a video that Kyle came up with this week or last week, is very recently. And when I watched this
week's video,
this week's video, okay.
Yep.
And as so many of your videos, Kyle, you just have that bad habit of applying common sense to the nonsense that is spewed at us, right? And so he put this video out, and I just had to laugh because, I talked about this, I don't know, last year or something like that, saying, yes, that is exactly the point. How in the hell could Wernher von Braun? Well, he knew, right? He totally knew. And they're making a completely different story. But so, Kyle, is there anything you want to say about this before we play it for the audience? Any intro or anything like that?
Go for it. Nope.
All right, cool. All right, guys, well, let's check it out. This is really good. Pay close attention to this because, boy, talk about sticking your foot in your mouth. Take it away, NASA.
Previously, I noted how if I were to jump off the top of a ladder, it is going to hurt a lot more than if I were to jump off the bottom of a ladder, because the more time I spend falling, the faster I'm going to fall. I then asked a bunch of different globe earthers, if the Earth is a globe and the ISS is continually falling around the world, why isn't it increasing in speed? The globe earthers gave me a wide range of different answers to that. Now please listen carefully to how Wernher von Braun describes orbital mechanics.
Now, what exactly makes an orbit tick? Imagine you put a gun on top of a mountain and fire it in horizontal direction. The gravitational pull of the Earth will pull the bullet down towards the ground, and after having traveled a certain distance, the bullet will finally strike the ground. Now, as we increase the muzzle velocity, the bullet will travel farther. And at a certain speed, the curvature caused by the gravitational pull of the Earth, which pulls the bullet down, will exactly match the curvature of the Earth. The bullet will then keep on flying around the Earth and will fall and fall, never being able to reach the surface of the Earth until it finally hits the breech of the gun from the rear. This is an orbit. You can establish such orbits at various altitudes. Theoretically, you could establish one immediately above the ground, but of course interference with the atmosphere would slow the bullet down and the orbit wouldn't be stable. So we have to go outside of the atmosphere. But once we are outside of the atmosphere, we have a free choice of any altitude we want. And the higher we go, the slower will be the velocity required to balance the gravitational pull of the Earth.
Balance the gravitational pull of the Earth. Now pay attention to the way he describes what that means.
For it is the centrifugal force in the curved orbit that cancels the gravitational pull of the Earth and keeps the object in its stable orbit.
For it is the centripetal force in the curved orbit that cancels the gravitational pull of the Earth and keeps the object in its stable orbit. So gravitational force is a force that needs to be canceled in order for orbit to be achieved. And when it gets canceled out, so that it doesn't decrease in altitude, that is what is considered a balanced orbit.
The Moon has been doing this for a number of million years, and the Earth is orbiting around the Sun, so the principle is well known and proven in Mother Nature's pattern of things.
All right. So in order to achieve an orbit to where this yellow ball will not spiral down to the ground, the pull of gravity represented by this arrow needs to be canceled out by another force. And if there is another force coming upward that will cancel it out, yeah, sure, that could possibly prevent the ISS from gaining speed. But what force did he claim was canceling out the force of gravity?
Okay, so I kind of want to interject here that it is the mainstream science position that, you know, we're all familiar with what supposedly centrifugal and centripetal forces are, right? Well, at least what they've told us. So what they've told us is that centrifugal forces are like a merry-go-round, okay? So if you get on a merry-go-round, you spin it up really fast, because of that fantastic edge velocity that's whizzing around at the outside, it's going to pull you to the outside and eventually throw you off of that merry-go-round, right? And then they have defined centripetal forces as their best example for that is they say, well, if we have an ice skater, right, for example, and they have their arms out and they pull their arms in and reduce that mass that's you know, having to fling out there, then the centripetal force will be increased and that will cause you to spin even faster, right? Well, now they will also say that centrifugal force, and this, I'm dumbfounded. I have no words for why they say this, but they say that a centrifugal force is a fictitious force. It's like, what? It's not a fictitious force. It's not even a fictitious force. It's a very real force. You know, it's demonstrable. You calculate everything. Now, the one that is a fictitious force is, of course, the one they're claiming is a real thing, and that's the centripetal force. There's nothing at all that's pulling anything inwards at all. And when we get through with this video of Kyle's, I'm going to show you a video that Jeran did a couple of years ago that's absolutely going to blow your mind what they're teaching to the kids in school, all the way up to college level. And their logic is so unbelievably flawed that it'll just leave you dumbfounded. It absolutely will. So I wanted to just throw that out there. They're saying right out of the box, centrifugal force, not real, centripetal, real. Nothing could be further than the truth. And if I'm wrong, guys, correct me, but I don't think so. So let's continue on.
Let's listen to that again real quick.
For it is the centrifugal force in the curved orbit that cancels the gravitational pull of the Earth and keeps the object in its stable orbit.
He said centripetal, right? Or did he say centrifugal, which is another pronunciation for centrifugal force?
Centrifugal force, or sometimes mispronounced centrifugal force.
Centrifugal or centrifugal.
All right. So it turns out there's no such thing as centrifugal force.
It's fictitious. It's an illusion.
It's the word we give to this thing that feels like a force operating on you if you are the water in that bucket.
Ready? Yep. All right, let's do this.
It's a thing that feels like a force to you, that if you spin it around fast enough, it'll rip your freaking arm out of its socket. That is a fictitious force. Am I missing something here, guys?
Well, I must be said that in that sense, for me, is a kind of pseudo is the pronunciation, no? Pseudo force in terms
Pseudo,
of that.
yep.
Yeah, that there is not exist. You need to create momentum to have that quote unquote force. So it's like like a condition based on other thing. I think they trying to say in that way. Maybe I express myself a little with confusion, but what they're trying to say is the outcome of something, a movement. It's like the inertia. The inertia is a force, or is something that you need to first do something to have that result. You know what I mean?
Yes.
That is what they're trying to tell in terms of the pseudo force, because it's not the force itself, it's the condition or the outcome of other dynamic.
Well, it's the result of an object being launched away from you. And so that tells you automatically right there that it's going in a certain direction, and that's away from you, not toward you. So,
but they declare as a pseudo force in every scientific book or Wikipedia, whatever you want to name it. You have that definition, like it's the rotation, it's the action of something rotated that give that, but the actual force in terms of that is the rotation, But it's not a force either. It's it's a little bit confused, but I understand it that way.
Yeah. So I'm just looking at, a pseudo force. I just looked it up. It's called a fictitious force. Of course, Coriolis is called a fictitious force, and for good reason, because it is an illusion. It is an optical illusion. There is no real force going on there. So it is actually correct to say that it is a pseudo force. Mostly because it doesn't have any effect on anything physical. It is an optical illusion, nothing more, and therefore it's fictitious. But, when you compare the Coriolis to something that is as real as, spinning a merry-go-round, or even, a jet engine, when they get those things that are getting up to 1,000 miles an hour, the blades on those engines, there is such a stress, such an incredible force on those things that they can literally penetrate steel like hot butter, right? So I'm sorry, but I'm just not seeing it as being fictitious, not in a million years, but that's just me. So let's go back to this.
Wasn't it Mercedes who had to build their jet engine specifically to take that?
Rolls-Royce. Rolls-Royce, yeah.
The Rolls-Royce, that's right. Yeah. They had to put all kinds of armor plating stuff in there to make it so those blades wouldn't shoot through it.
Yep. And that's because that was a video that dealt with edge velocity, right? Because the ballers will say, they don't want us to believe that the stresses generated by 1,037.5 mile per hour edge velocity on the Earth will do anything to it, right? Why? Because they will change the definition of it and make it an angular velocity and say, "Oh, you stupid flat earthers, it's just a 0.00000067 RPM, right?" Well, yeah, that's pretty freaking slow, right? That's really slow, but that's also at every point from the center of the sphere all the way out to the edge. By the time you get out to the edge, you're traveling at 1,037.5 miles per hour, and the centrifugal stresses are said theoretically then to cause a distortion in the Earth of something like 42 miles, 24 miles on each side. So that's where you get your center being elongated, or not, the center being bowed out, right? Kind of has a belly, what do they want to say about it? And they're saying that that's happening because of those stresses of the Earth rotating. But yet you would think that you would see that in the water, right? Why isn't it showing up in the water? Why doesn't the water, all want to go right to the center of the equator and have a massive, huge buildup there. Well, the water doesn't build up there. And when you drain the oceans and you actually look at the picture of the Earth, supposedly with the oceans drained, it's hardly a sphere, guys. So they're trying to make comparisons that water is on par with, you know, all the metals that are in the minerals, all this stuff, and that somehow out of it comes almost a perfect sphere, which is complete nonsense. And again, goes against their own, you know, physics about what's happening. But then, of course, when you ask, well, how come how come we're not getting a big buildup of water on the equator? Well, you silly flat earthers, it's only 0.000697 RPM. It's like, whatever, dude. Okay. All right. So let's continue on with Kyle's video here.
What's happening is, because you're getting spun, you have an urge to fly off at a tangent of that circle. Okay? That urge to fly off that is prevented, you will feel as a centrifugal force.
So in this instance, the bucket and the weight of the water is what is preventing the water from flying off.
Those two together are what we call a centripetal or center-seeking force.
So the weight and the bucket are creating the illusion of centrifugal force, and the real force in play is centripetal force.
Notice that there is no force acting on the ball that goes directly outward, away from the center. What we often hear called a centrifugal or centrifugal force. You know, the force you seem to feel when you lock hands with someone and you both spin around.
No, wouldn't it be called wouldn't that be called a vector force, the centrifugal force? Because you're right, if something's going around in a circle like that, if you were to let go of the string or the tether that is got a hold of it, the last place that you let it go, the direction that it's heading is where it's going to take off and head. It's not going to continue on that curvilinear path. It's going to immediately switch over to a linear path and go straight ahead, right? But they're saying that doesn't happen. They're saying that's a pseudo force. They're saying that doesn't exist. And yet, what the hell are they talking about? It's obviously there. So, and like I said, you're gonna die when you see how this whole thing of centripetal and centrifugal, force comes about, and it's 0.000697 RPM, right? So that's a really, really low figure for Earth. But again, it's all about the edge velocities. And I actually had a guy at one of the Flattoberfests that worked it all out. And one of these days, I really have to go through that, and I'd love to. I'm gonna present that because he worked out all of the stress forces on it. And I have to admit, it is mathematically heavy. It's probably a little over my head. But this is one of those things that I'd like to hire like an expert mathematician for, like from Fiverr, because they have all kinds of people like that, and say, okay, here's what we are told is going on with the Earth, and here's the formula we've come up with. Hire somebody from Fiverr and say, okay, validate it or invalidate it and tell us why, right? And if he validates it, well, then he's just a third party, right? He's just somebody, hey, I do math. I got a PhD for math. And then we can take that to the ballers and we can say, okay, ballers, it appears that what really does matter is that edge velocity, right? And so how do you explain that we're not getting things flying off at the equator, right? Why are we not seeing anything like that? Why do we see lakes that are as calm as glass, right? Why is it that when we are going through perihelion and aphelion and periapsis, right? All these close and far orbital turns that dramatically will cause Newtonian forces to be felt because they're accelerative forces. Why can't we measure them? Why? We should be able to measure them. Not only should we be able to measure them, but we should be able to absolutely predict them, like in the wintertime, right? In the wintertime, when we go through periapsis, when we're going through these really rapid changes of direction and velocity of the Earth going around the sun, Well, why can't we measure that? Right? This is something that NASA cannot and will not answer. The ballers will just come up with their own stupid math and their own stupid formula that doesn't make any sense. And that's why I think, like I said, this is a good GoFundMe project. And I have been getting some good GoFundMe money donations in, which is great for this, guys. And I think this is one of the things that I'm going to, dedicate some of that money to. I'm going to hire an expert mathematician and then say, here it is, do it, solve it, and show all your work, please. So, all right, so let's continue on with this. And I'm sorry. And guys, if you want me to stop at any point, so you can comment on this, feel free to. I know I talk a lot, but you are more than welcome to throw in anything else you feel is necessary on this. Okay? Okay, here we go.
Cool.
And you feel pulled straight back, or when a car you're in turns quickly and you're suddenly thrown away from the center. The thing is, this seemingly outward directed force isn't a force at all. It's actually just an object's inertia, the path the object would take if no other forces acted on it, being blocked by a force, a centripetal force.
So it doesn't really matter which one von Braun said, since centripetal force and centrifugal force are actually the same thing in the end. Perhaps this is why people tend to mesh those two together and just say centrifugal. So, in order for orbit to be achieved, gravity needs to get canceled out by what?
For it is the centrifugal force in the curved orbit that cancels the gravitational pull of the Earth and keeps the object in its stable orbit.
Gravity has to get canceled out by...
Pause it here.
Okay.
I've watched it a lot of times, and every time I hear that, I keep hearing him say centripetal. And so, but people, oh no, he's saying centrifugal, or centrifugal, and so there's still this huge debate on that. But I don't know if you're hearing what I'm hearing or not. Is it just me?
No, I hear it both ways, and honestly, Kyle, he's both on wrong counts. He's wrong on both counts. Right? It doesn't make sense the one way, and even if he's right in the other way, it doesn't add up to what we're seeing. And I'll get to that in a minute, to show you that. But no, I think you're right on the money. Whether you look at it as centrifugal or centripetal, they're two very different forces. But isn't it interesting that they're calling the one that actually would be qualified as a force, a pseudo force, which like I said, I don't see that. I just think that's ridiculous. So.
Okay. Yeah, go ahead.
Okay, let's go.
Its stable orbit.
Gravity has to get canceled out by centripetal force, which in this case is gravity. So according to von Braun, the downward force of gravity gets canceled out by the downward force of gravity and prevents the satellite from spiraling down to the Earth. Please tell me you see what is wrong with this picture. There is no upward force canceling out the downward force.
He knows a lot about all kinds of stuff. Professor Dave explains.
Okay, and I'm going to apologize for Kyle for subjecting you guys to Professor Dave. Bad Kyle, but this was actually a good clip to use.
I love it.
Oh, this guy.
Whenever I get the chance, I got to kind of include his stuff because its intro is just so funny.
Oh, I know. God, I've been collecting clips where he just literally sticks his foot in his mouth constantly, and we're going to do a little expose on that one of these days for Mr. Professor Dave, because he is the most condescending asshat I have ever seen, honestly.
Yeah, I agree.
So, all right, so let's listen to Professor Dave. Here we go.
So how do these objects stay up there instead of falling to the Earth? It's not because there's no gravity. In truth, gravity is almost as strong in low Earth orbit as it is on the surface of the Earth. The reality is that these objects are, in fact, falling to the Earth. It's simply that they are moving so incredibly fast that they fall to the Earth at the same rate that Earth's curvature is produced, always falling but never landing. This is why astronauts experience weightlessness, because they are literally in free fall.
Therefore, they should be continually increasing in speed since there's no force to prevent gravity from causing them to do so.
That's right. Because why? Because what is the rate of acceleration? 9.8 meters per second squared, which is an acceleration and they don't put a limit on that acceleration. They just say, this is it from now to infinity. And so you have to ask yourself, what is it all of a sudden that has capped that, right? That's what I certainly have a question about, and asked that many, many moons ago. And I don't think we're going to get an answer on that that's forthcoming. Do you, Kyle?
It's just the magic zone. If it's a little bit farther away from this magic zone, then it flies off into outer space. If you're just under it, then it falls down to the earth. And yeah, I've got a video coming up. I'm going to talk a little bit more about that.
Awesome. Okay.
I have an idea. I won't mention it aloud. I'll tell you, Bob, when we are off the show. It's just I don't like to give them ideas. But yeah, I have a good answer, I think, for what, in fairy tale Narnia land, what they could say to go against this.
Yeah, I come up with stuff like that all the time. And remember, let's not forget, guys, that it took a flat earther, specifically Good Times for All, or Zachary Zabala, if you prefer, to show how under our model of gravity and these forces, how we could actually make water bend. We're the only ones that have done that, guys. We're the only ones. Yep, let's continue on.
People love to use this whole ball and string example to demonstrate their understanding of how orbits work. But what gets overlooked in this is the fact that the string doesn't reel the ball inward. And since gravity would reel the ball inward, this whole example is a misdirection. Now, here is a yellow ball with one force acting on it. As such, it is an imbalanced force. And since the ball has nothing to oppose it, that ball should move downward. And when an equal and opposite force is introduced, that is when we have balanced forces, and that ball shouldn't move anywhere. When we add a third force, we have one set of balanced forces and an imbalanced force. So that ball should move straight to the right. In this instance, we have two imbalanced forces. The horizontal force does not cancel out or balance out the downward force. So the ball should move diagonally and to the right. Now let's see what that looks like around a ball.
If you apply force perpendicular to it.
Right, and mind you guys, this is called a vector force now because we have multiple directions. So we have a net vector that's acting on this object.
Its motion for a short time, the object will deflect, as shown. Its direction changes. Now let's apply the force again, perpendicular to the new direction. The object deflects again. Let's repeat this process. Now, observe the shape the object traveled. It's very close to a circle. If the time interval of applied force is significantly smaller, you will get a more perfect circle. Which means if an object is always acted upon with a force perpendicular to its velocity, the object will move in a circle. This force is known as centripetal force.
But here, this is based on a downward force that doesn't cause things to speed up as they fall. When we have that, this is what that looks like. If you show that around a ball, it will result in a downward spiral. It's time to get out there and make some noise. Abolish NASA! Let's do this thing! This video has been brought to you by the Flat Earth Institute of Science. Thank you all for watching.
Excellent. All right. Very good, Kyle. And yeah, I couldn't agree more. They just don't account for all of their forces, and they seem to either obfuscate or misdefine real forces, or things that certainly act like real forces, right? So I honestly cannot, and Globers, hey, put it in the comment section if you can say anything other than I'm just a stupid flat earther and I just don't understand, and you can actually explain to me why what they're calling here is not a force, and why I'm wrong about this, then by all means put it in there. I'll give you a special mention on the show. But you know, I know all I'm going to get is, you know, how dumb I am, right? And my brain is flat.
Einstein, who said, when the facts don't match the theory, change the facts.
Exactly. Yep.
Just this whole thing about them kind of treating it like a straight line all the time, as we just saw. It's crazy. It's just crazy how they just ignore the whole acceleration of gravity in their concept. They invent these rules and then they don't play by their own rules.
Yep, absolutely. So now I'm going to kind of add a little bit of cowbell to that point that we just made. I'm going back to a video that Jeran actually made. I think the first time this actually came out was in like 2018 or 17, something like that. I don't remember the date. This came from the Jeranism Mirror channel because it's not on his current channel, but he did recently do a short clip of it, but it doesn't have all the good information that this one has in it. What he's going to show here is pretty much the common explanation that NASA gives for these forces that they're defining, and they are nonsense, complete nonsense. So I'm going to go ahead and play this, and I'm going to point out, well, I think it'll be obvious to you, you know, what the problem is, but they're essentially saying that centrifugal and centripetal forces are, well, they're just wrong what they're saying. I'll comment on it as we go. Let me just play this. Let's go.
Because if you begin to invoke our own senses and to question what they have built, scary things begin to happen as the world they built begins to show signs of being a worldview, a religion masked by mathematical fact. We've all been had, ladies and gentlemen. Our senses can just watch the infamous spinning merry-go-round of death or the gravitron and see that when spinning, you will fly off the merry-go-round, and if there's no padded walls in the gravitron, well, you'd fly off that as well. We can read this article about the spinning merry-go-round of death, and this guy uses math to show why the man flew off while only going at a linear velocity of 16 miles per hour. He even tells us here why it's a fake force. The actual acceleration, he tells us, is towards the middle. Again, to stay on, we need balanced forces, which the Earth, of course, has, we're told. He says in his article in regards to fake forces, and this is where the fake force comes in. Fake forces are not interactions between two objects. Instead, they are make-believe forces that we need in order to make objects in an accelerating frame behave as though they were in a non-accelerating frame. Fake forces let us use Newtonian mechanics in a place where it doesn't really work. He says, everyone has experienced these fake forces. Here you are in a moving car. The car turns to the left, and what happens? You get pushed to the right side of the car. Now, what force was it that pushed you? Or better,
I would have to call that centrifugal force. Would you guys agree?
Yeah, I'd have to say so.
I mean, it certainly sure as hell isn't centripetal. It's not pulling you in closer to the direction that you're turning. It's not pulling you in closer to the axis of rotation. It throws you away from it, which by definition is centrifugal. And again, it's a very real force, very real. And in fact, they use one of these stupid pieces of technology that we just covered, I think last week or a couple weeks ago, where they use this centrifuge basically. Well, they use a centrifuge for a lot of things for centrifugal forces. But most recently, they're going to put a spacecraft inside of a centrifuge and spin it up going around in circles really, really, really fast. You know, kind of like putting a ball inside of a sling and then throwing it up into space, right? That is centrifugal force, right? But what's this? That doesn't exist? What do you mean it doesn't exist? Then what are we seeing? What do you call that? Well, I think they're going to tell us, and this is where it's really going to blow your mind. Let's continue.
better yet, what object interacted with you? Surprise, there was no object pushing you that way. You want to say there is a force, even though there isn't one. This is the essence of the fake force. And yet, everything flies towards the outside. If a car was turning in a constant circle, you'd be pushed towards the outside. When the spinning merry-go-round of death is going around, the person flies off to the outside. We see it every day, everywhere. But here's a place where, again, because of Newton's description of what a force actually is, it changes the reality. So now you have to believe that we are being pulled towards the center. They actually teach this to children. Check out this site and let me read to you how they explain this one, and we can all laugh at it together, and hopefully you can start to see why I say there's no possible way that we're spinning. So the site is called the Physics Classroom. This is, I guess, for children. It starts out talking about acceleration, then gives the geometric proof of inward acceleration. But we're going to go down a little bit further here so we can see an experiment or a test. So let me read.
Now, one thing I'm going to say, the first thing we're going to catch flack for is they're going to say, oh, Globebusters, what are you doing using a site for children? And which, frankly, is a stupid argument, because what difference does it make if it's for children or if it's for adults? If it's the truth, then it's the truth, right? If it's some... Go ahead.
That's like where you should find the foundation. This should be put down to its most simple terms, and we build on those basic building blocks that we're supposed to be taught as children, and then we get up to the complex concepts that are supposed to be taught in college. But no, they go ahead and they try to flip it all around, and we're going to just throw the complex concepts as children, and then, oh, we're going to teach you all those foundations later on. And it's all backwards. You don't learn calculus in kindergarten. You're supposed to be learning those basic building blocks there. And so I like to look at those basic things, and that's the way it should be in science, is looking into the core foundational concepts in the early grades of elementary.
Exactly. And that's one of the reasons I really like that series that you and Karina, Karina is Kyle's wife, very lovely lady. And they did a series, it was something like the basics of physics destroyed, or basics of science.
Modern Earth Science Destroyed.
Yeah, Modern Earth Science Destroyed. And basically, so they're using an introduction, right, to physics book or science book. And it's so funny, Karina's reading the book and she doesn't even get in a paragraph, and instantly they're already jumping to the conclusion, right? And it's like, well, wait a minute, how can we have a conclusion here when we haven't even built up to how you guys came up with these conclusions, right? It's pretty silly to put those in a basic type of text for children. In fact, like Kyle said, that should be where it is broken down to the most basic element, is for children, and then expanded upon as an adult, not going completely against it and then having people ridicule this material because it was made for younger students instead of older ones. That's just stupid. Okay? So let's listen to Jeran and continue on.
Read you this from Direction of the Acceleration Vector. It says, objects moving in circles at constant speed accelerate towards the center of the circle. The acceleration of an object is often measured using a device known as an accelerometer. A simple accelerometer consists of an object immersed in a fluid such as water. Consider a sealed jar that is filled with water. A cork attached to the lid by a string can serve as an accelerometer. To test the direction of acceleration for an object moving in a circle, the jar can be inverted and attached to the end of a short section of a wooden 2x4. A second accelerometer constructed in the same manner can be attached to the opposite end of the 2x4. If the 2x4 and accelerometers are clamped to a rotating platform and spun in a circle, the direction of the acceleration can be clearly seen by the direction of the lean of the corks. As the cork-water combination spins in a circle, the cork leans towards the center of a circle. The least...
Okay, so if you're not seeing what's coming up here, they are about to pull the old switcheroo in such a way that it is so absurd, such a huge lie and such an absurdity that it'll boggle your mind, what they're trying to pass off as a centrifugal detector, or you could look at it as a density type of detector as well. But watch what happens here, and look at the logic they use, and just say, wow, NASA, you're amazing. Let's continue.
massive of the two objects always leans in the direction of the acceleration. In the case of the cork and the water, the cork is less massive on a per milliliter basis, and thus it experiences the greater acceleration. Having less inertia, owing to its smaller mass on a per milliliter basis, the cork resists the acceleration the least and thus leans to the inside of the jar towards the center of the circle. This is the observable evidence that an object moving in a circular motion at constant speed experiences an acceleration that is directed towards the center of the circle. This.
Okay, do you guys see the obvious problem with this? If not, there was a video. Yeah, this is huge. There was a video that Smarter Every Day did a while back where he took a minivan and he put some balloons with helium in them at the back or somewhere in the middle of the minivan.
In the car,
okay?
yeah.
In the car, right? And he took off, and what you might think would happen was that those balloons would go back. Well, that isn't what happened at all. When he took off, those balloons shot forward. And it's like, well, that's kind of counterintuitive until you think about what's actually happening there. Well, what did happen there? Well, when he took off, basically what happened is that the air that was free to float around inside of the van itself, and of course all the windows were up and everything, was all forced backwards, and it then kind of built up into a much denser medium at the back of the van. And since the helium balloons were less dense, it forced them to go forward. So, okay, yeah, that makes perfect sense, right? The air goes back and it's forcing those balloons to go forward. And that was a perfectly understandable and logical explanation. Now, this is essentially the same exact thing, guys. And I'm going to back it up just a little bit and watch this and what they're trying to tell us here. And just, don't headbang too much. Here we go.
Water combination spins in a circle, the cork leans towards the center of a circle. The least massive of the two objects always leans in the direction of the acceleration. In the case of the cork and the water, the cork is less massive on a per milliliter basis, and thus it experiences the greater acceleration. Having less inertia, owing to its smaller mass on a per milliliter basis, the cork resists the acceleration the least and thus leans to the inside of the jar towards the center of the circle. This is the observable evidence that an object moving in a circular motion at constant speed experiences an acceleration that is directed towards the center of the circle. This is complete nonsense. The water is being pushed to the outside, just like in the gravitron, just like in the merry-go-round of death, just like in any merry-go-round, just like in anything spinning. The water is flying towards the outside, which is pushing the lighter cork towards the middle. This here actually says, the cork of the water accelerometer points inward towards the center of the circle when placed upon this rotating platform, thus indicating an inward acceleration for circular motion. Wow. Let's read a little.
Can you believe that? Can you people believe that? What they are saying here? Wow. I mean, how far does your head have to be up your butt to believe that?
Yeah, that's insane. I mean,
that's crazy.
A child can go out with their hand and, a ball tied to a string and just spin it around. It will never fly to the center when you let go of it, ever. Guaranteed. That's one of those physics things, That's just how it works. This is crazy.
Yeah. And this is not the only text that we found like this, guys. This, like I said, Kyle has found stuff like this, very similar. I've run across it. And there's also another one that is absolutely amazing that was done by Rob, a guy named The Bloody Truth, if you're familiar with that channel. And this is on the 24-hour, 24/7 Globebusters channel, but I don't know if he still has it on his channel or not. But in this, he does an expose on the teachings of the Coriolis force, right? From what they tell us when we're in the earlier grades, elementary school grades, and then they kind of take a break from it, and then back in high school, they jump back into it, and they're counting on you not remembering certain things about the Coriolis force. And then they completely do a 180 and flip it around and make a completely different story than they did that they taught that they were taught to the children in elementary schools or in the primary schools. Well, again, why would it be any different? There should be no reason in the world it should be different. In fact, it should be even truer on a more basic level. But instead, they're flipping it totally around. And this is a very, very common tactic that they use. So, you look at this and, this is just one example that they do this in. It's absolutely amazing.
The one thing that drives me insane is when people, well, why would they do that? Okay, I'm going to read you a quote. This is from 1981 from William Casey, the CIA director, from his very first staff meeting. We'll know our disinformation program is complete when everything the American public believes is false.
Yes.
Now, I didn't say that. He did. So if you want to ask why they would lie, go ask him.
Yeah, well, and the fact is, it's like they're saying, why did they lie? But the point is you can see quite plainly that they did lie. So, asking us, well, we have our reasons, and I'm sure we could come up with our reasons, and we have, and you can come up with your own. But the point is that they did lie. And that's the whole point. They did lie. And whatever value you want to assign to that, that's up to you. But eventually you've got to start putting together a preponderance of evidence for what you think might be the real reason for it. And if you are on the right track, you will find that that evidence falls right into line everywhere you look. And lo and behold, that's exactly what happens. This is happening all over the community. So many people have discovered these anomalies, right? Which aren't anomalies at all. They're blatant intentional misdirections. And wow, amazing. So let's finish out what Jeran has to say about this, and they're gonna back it up with their math here and all this stuff. And yeah, yikes.
A little bit further here, it says another simple homemade accelerometer involves a lit candle centered vertically in the middle of an open air glass. If the glass is held level and at rest, such as there is no acceleration, then the candle flame extends in an upward direction. Okay, correct. However, if you hold the glass candle system with an outstretched arm and spin in a circle at a constant rate, such that the flame experiences an acceleration, then the candle flame will no longer extend vertically upwards. Instead, the flame deflects from its upright position. This signifies that there is an acceleration when the flame moves in a circular at a constant speed. No, again, the flame is being pushed towards you because the heavier air is being pushed out. Complete and total nonsense. Look down here, it says, thus far we have seen a geometric proof and 2 real-world demonstrations of this inward acceleration. At this point, it becomes the decision of the student to believe or not to believe. What? So it's up to the student. And then look over here, there's a happy little student, and she says, I believe in physics. This is classic, folks. Think about what they're saying here, that when something is on a spinning platform, that it's being accelerated towards the middle, and the evidence they give is this rotating platform, which clearly shows that the water is being pushed to the outside. Think if you had 2 half-full milk gallons, okay, in each hand, and you outstretched your arms and started spinning. The milk would not fly towards you in the middle. It would fly towards the outer edges of the carton. However, according to this, the fact that the air in the bottle would come towards you proves inward acceleration. Give me a break. I mean, the experiment they show is simply laughable at best. Of course, if you spin this turntable, the cork goes towards the middle. It is less dense than the water which is being flung to the outside. All you need to know to see this deception is how a centrifuge works. When you spin a centrifuge, the heaviest items, the items that are more dense, fly out, and the less dense items come in. Not because there's an inward force, no. So this is for the Wikipedia from centrifuge, and it says, a centrifuge is a piece of equipment that puts an object in rotation around a fixed axis. In parentheses, spins it in a circle. Okay, so far we're on the...
Boy, aren't we lucky that we had NASA around to debunk centrifuges, right? Something that's used every day in science. And what we just learned before this directly flies in the face of what's going on here, separating the more dense matter from the less dense matter. And it's unbelievable, but that's their game. Also, what was it? Colm Gibney says, Globebuster, centrifugal force debunks spinning planets. Expect a very hard fight on this one. I agree. Centrifugal force debunks spinning planets. Absolutely. But I'm not expect a very hard fight from who? From the ball earthers or from the flat earthers? Because, as we all know, we know nothing. The odds of these planets being terra firma and actually subject to these forces are nil or less than nil. So I don't know. And of course, we have our own so-called theory of gravity, but that's why we've kind of renamed it to the downward electrostatic vector. And we'll be explaining that again here shortly. So anyway, okay, let's hear Jeran out and then finish it up.
The right page. Applying a force perpendicular to the axis of spin outward that can be very strong. The centrifuge works using the sedimentation principle, where the centrifugal acceleration causes denser substances and particles to move outward in the radial direction. At the same time, objects that are less dense are displaced and moved towards the center. So again, do you see what they're doing here? They just described that exact action, but said that it's actually causing a force. The cork, which is less dense than the water in the accelerometer, is coming towards the middle. No, it's because the heavier items are flying towards the outside. Now, they can't tell you that. Why not? Because you're going to start to question, how am I spinning on a spinning sphere? How am I not flying towards the outside? All the heavy items in a centrifuge, in a merry-go-round of death, in a gravitron, all those items are pushing the heavier and most dense items to the outside. But on the Earth, it's the opposite. All the heavy items are pulled towards the inside, and the gases and the atmosphere is being pushed to the outside. It makes no sense. The heavier items get pushed to the outside in a centrifuge, which would be me, you, rocks, water. Those things would be flying towards the outside, and the lighter things, like the cork, or in this case, the atmosphere, would be pulled to the inside. It truly becomes more and more insane the further you go. If we go to Cool Cosmos and ask, why don't we feel the Earth move? It stays.
Right. And of course, the reason that the lighter things, he kind of I don't know, maybe a misnomer there. He said would be pulled to the inside. It's not that they're pulled to the inside. They're displaced to the inside where there is less density, less dense material, right? Because after all, that's what the centrifuges do, is they separate from the more dense from the less dense material. And so, yeah, so that's what's really going on here. But isn't it amazing how they have pieces of technology that operate, on well-known, classical physics models, and then they turn right around and discount them and say they don't exist. Kind of like the ether. The ether was proven unequivocally by the Sagnac experiment. It was also proven by the Michelson-Gale experiment. And yet, because Einstein was able to come up with an equation that dismissed it mathematically, even though it was completely against his own thoughts on the ether, Einstein himself said, geez, I can't imagine a world without the ether. And every physics laureate, Nobel physics laureate, has said, yes, the physics exists, or the ether exists. It's real. It's absolutely there. But, because everybody has to follow that Einsteinian nonsense, Piper that they put out there, well, then they have to accept the fact that the ether doesn't exist, even though we have technology like fiber optic gyros and ring laser gyros and all interferometers that are all working on this effect that is undeniable and is the most precision test equipment that we have, capable of measuring theoretical Earth movements and perihelion and periapsis and all this stuff, but it doesn't, right? It doesn't because we're not moving, but they have to take that apart at every corner when it disagrees with the line that they're trying to push, and we all know that. So
yeah, I've been talking about this on my debate board recently with a guy named Rory, and we're talking about the centrifuge ride and how there's an outward push on the wall of the centrifuge, the carnival ride. And he's claiming, oh, well, that wall is pushing back on you. And we're getting into Newton's third law here, where if you push on a wall, that wall pushes back. And I'm like, really? That wall pushes back on you? How much weight is it pushing back on you? Because, you know, if I go punch a wall, I can apply weight to a wall, but is that wall applying any weight back on me? Is that really pushing me? So I've got a video coming out in about 2 weeks that will be on Newton's third law and just how I think it's totally bogus. And so, yeah, it's going to be one worth watching.
That's really good because, you know, there was a video that I highlighted by a guy that had a master's degree in, what was it? Applied physics or something like that. And he was saying that Newton's third law actually disproved rocket propulsion or actually proved rocket propulsion in space, something like that. And the way that he was presenting it, and I'll have to show you this video, but I took it as is like, no, what I'm seeing it as is that Newton's third law is actually the thing that is disproving, you know, rocket propulsion in space. So, and you're saying now that you think it's the other way around? Or did I misunderstand you?
I'm saying that the wall doesn't push back on you. You can push on the wall, but there's a lot of the molecular bonds within the wall that are holding themselves together. So it's not, there's no force pushing you out. It's just the molecular bonds aren't breaking. And so it's kind of a perpendicular forces that are tying those bonds together. And so my example that I'm going to use is dropping a bowling ball on the floor. Okay, if you drop a bowling ball on the floor, Newton's third law says that floor is going to have a normal force that's going to push back on you. But there's a huge difference between dropping a bowling ball on the floor versus dropping a bowling ball on water. And the difference is the molecular bonds that hold the two together. And so the water, the molecular bonds are going to break and split apart. And so the bowling ball is going to just fall right through. But yeah, the floor, the molecular bonds are a lot stronger. And so it's not going to fall through the floor.
Yeah, I understand that. But also another way to look at it, I guess, Kyle, and this is the way that I'm seeing it, you know, because when the guy was doing his demonstration, he's saying, you know, I can push on the wall and, you know, if I exert 10 pounds on the wall and it doesn't go anywhere, then basically we remain at a state of equilibrium because the wall is kind of countering with a 10 pounds of counter push, right? So I don't know if this is a semantics thing or what, but I can kind of see how the idea of the wall pushing back could be, you know, deemed as legitimate. I don't know. We're going to have to talk about this because it's interesting.
Yeah, okay, well, the other example, so I've got two examples. One is the bowling ball on the floor. The other one is if I drop a weight on the floor, okay, I've got a 20-pound weight. I can put that on the floor, and now the floor is going to be pushing back on that weight with 20 pounds, right? That's what they claim. So I pick up that weight, and that floor doesn't move anywhere. Oh, I thought it was pushing me. It's not moving anywhere. You know, if I lift up the weight, that since the floor is pushing, then it should be rising up, right? But it doesn't move anywhere. The wall, when I push on that wall, and then all of a sudden I stop pushing on it, the wall doesn't move anywhere. Well, what happened to the push? It just disappeared. You know, so that wall, if it was pushing, it should actually be moving inward, but the wall should be enclosing around the person and pushing the person inward. There should be some kind of movement. You know, if the moment I take my hand away, it should move.
Well, what if you use something a little less viscous than a wall, like a Play-Doh or something like that? Then what's happening there?
Well, Play-Doh, when I push on it, I'm going to leave my handprint in it, and then that handprint's going to stay there. It's not going to bounce back out unless maybe Jell-O might do that a little bit more because of the weight on the Jell-O ends up kind of. I guess there's different things like skin, for example, has an elasticity to it. And that's kind of, again, going back into the strength of molecular bonds.
Right. But you could look at it also as that, you know, you're pushing a less dense material into a more dense material until it gets to the point where it is matching your forward force going into it and generating a state of equilibrium and stopping your hand from going any further. right? So I don't know. I mean, I'm not disagreeing with you, Kyle, and I find it interesting.
It's fine. Totally okay.
But
Totally
yeah,
okay.
and I'm all for getting to the bottom of this because that's all I care about, you know. But yeah, I can certainly see how that can be looked at in different ways, and I am very interested in seeing what you have to say about it.
Yeah, I look at it and I say, yeah, the floor can't pick and choose.
Go ahead, Zach.
Like a super slow motion camera catching the ball actually hitting and see if the floor does like an indentation and then abruptly comes right back up real quick. You know, when you're dealing with types of frequencies and everything can be. I've seen concrete wave. So if you hit that right thing, maybe it does bow down a little bit and come back up real fast. I don't know. Yeah, that's a weird one. That is but I think that'd be a good way to test it. You'd have to look real close, real slow.
You have any comment, Aaron, on it?
No, I am a little lost in this, so technical stuff. I understand a little bit, but I am not really fan. I am with Kyle in terms of the idea that in this case, the example with the wall is pushing against you with the same force that you push the wall, things like that. Maybe I didn't explain very well because I am not the type of guy who are really, technical and detailing the explanation very deep. But that's, things like Newton, I think we can take things from Newton to apply in our real world, and it's fine, it's work. And I am more in the sense of the third law of Newton, debunk the model of the rocket pushing against invisible particles in space, in the emptiness of space. I am not thinking that you can have rocket pushing against what? In the vacuum of space.
Well, yeah, and that's exactly the whole argument.
No. For me, the third law of Newton, which is not from nature, it's from Newton. It's an explanation of a natural phenomenon. Debunks the rocket in the vacuum of space.
That's right.
Or the space is not vacuum, or they are using another type of technique. Of course, they are not going to space. They are not in space, etc., etc., etc. But I am not. I think more like you, Bob.
Yeah, and yeah, exactly. And that's my whole problem with rocket propulsion in space. Every single type of locomotion that we are aware of, and I mean every type, including ion propulsion, requires matter to be an intermediate. Because if you don't have something to act against to provide that third law, right, or a response to that action, then you're never going to go anywhere. And of course, the ballers and NASA wants us to believe that the rockets are actually going forward by not so much. They're saying essentially that the rocket fuel is burning enough and generating enough smoke, right? Whatever, particulate matter, that there's something then to push off of. But the problem is that it's, all of that takes place in a chamber that is closed on all three sides or on all directions except for one, and that's out the back. Well, when you start igniting gases in there and they start making particulate matter, because of the fact that the pressure on the outside of the rocket motor is 10 to the umpteen zillion orders of magnitude less than what could ever be generated in that rocket venturi, then essentially it will be evacuated all by itself, right? The gas will come out. It doesn't require anything to push it out. It will just be blown out because of the difference of pressure, and no work will have been done, right? This is the free expansion law of gas, right? There's no work being done. And if no work is being done, then there's no way then you can have any locomotion providing an equal but opposite reaction to propel something forward. And like I said, every single type of locomotion that we are aware of requires something to provide, something to work off of. When it's a boat, you've got the water. When it's an airplane or a jet, you've got the air. If it's ion propulsion, you have ionized particulate matter. But we're talking about a vacuum here. We're talking about nothingness. And they think that they honestly believe that they can generate enough matter in the vacuum of space to be able to offset the massive inertia and actually propel these rocket ships up to thousands of miles an hour. And it's just preposterous. You can demonstrate it that it cannot be done if you do it fairly. If you have a big enough vacuum chamber and you fire off a rocket in there, even if it puts a crap ton of particulate matter in there and gets it to maybe move a little bit, well, that's because it's a small box that they're demonstrating it in. You have to understand that they're using this little itty bitty, teeny tiny, rocket motor against the vacuum generated by all of outer space, which goes on theoretically for ad infinitum, right? There is nothing there to push against. It's just, it doesn't work, guys. And therefore nothing could work, not even ion propulsion, because you have to have particulate matter to be able to push, to ionize, to be able to push a charge against, to push away from. Well, if there's no matter there, or the matter is so fine or so barely dense, right? 10 to the negative 17 torr, then you're not going to ever be able to have enough mass there to work against. It just doesn't work. So, but that's something that NASA, they want us to believe that well, that's what's going on there. And if you look at it in the paradigm of like a gun, right? If you take a gun and you shoot a bullet, then what's happening is the bullet has the gunpowder in it, which then once the firing pin goes off, it ignites the gunpowder, which then causes an expanding gas inside of the case of the bullet, and the shell of the bullet, or the bullet itself, goes one direction out the barrel, and the back of the bullet is held in place by the frame of the gun, which of course is held in your hand or whatever, and basically secured to the ground by your body, right? So there's that is what satisfies Newton's third law of motion right there, okay? But say you had two bullets, right? And you could fire them both at the same time. You could have the gas and have a bullet on one side and a bullet on another. And if you could just fire them at the same time, well, then the two bullets are going to work off of each other, and they're going to fire equally as far in opposite directions out in space. Why? Because they have the mass of one another to work against. Okay? But when you don't have that, when you are just lighting up a big bunch of gas and it's being blown out before any work can be done due to the free expansion of gas law, then there is nothing there to do any work or provide anything to press against, right? It's as simple as that. It's very simple.
If I put 10 pounds of pressure on the wall, or if I'm putting it on the wall and I put something between me and the wall, is that object going to experience 20 pounds of pressure? Because the wall is pushing back with another 10 pounds?
No, it theoretically would be matched by the 10 pounds. It's just like if I walk around and if I'm 200 pounds and I'm standing on the ground, I'm exerting 200 pounds of weight, right? Or a force on the ground, and the ground is matching that, and therefore motion is stopped because equilibrium has been reached, right?
But the thing in between us isn't experiencing the pressure from both sides. It's only experiencing pressure from one side. It's not doubled the pressure because I've got an equal amount of force on the other side. So if I were to take two cars, okay, and they crash into each other, right? One's going 20 miles an hour, another goes 20 miles an hour. That's an impact of 40 miles an hour.
Right.
Isn't that
Well,
right?
that's when you have to take the mass into consideration of it also. And that's another thing, guys. We did a show years ago called Sunday Mass, right? And in this show, I showed that every physicist, every scientist, everybody has a completely different take on what mass is. Different states of mass, different states of matter. There's inertial mass, there's mass in motion, all these different kinds of mass. And, some will say that mass increases when it is in motion. And as mass gets towards the speed of light, then the mass becomes infinite, right? Which, of course, seems really ridiculous. But the bottom line is that's something else that has been very much convoluted. And I think that's what we're talking about here, Kyle. I'm saying that because of other factors, the mass and the makeup of the wall, yeah, I can't push through it. But if it was something else, I could push through it, right? So that's what we're talking about when we're talking about responsive forces, right? Or something pushing back the same way. So I don't know. It's a great discussion, something we'll have to contemplate on. But, it's one thing that's been very much obfuscated, though, by NASA for sure.
Yeah, I'm glad I brought it up just for the fact I got this new information that just came to me with the whole collision math about the two cars versus going into a wall. If you run into a wall at 10 miles an hour, that's all you feel is 10 miles, right? The impact. But if two cars come at each other with the same amount of force, it's double. So there's a huge difference between cars and a stationary wall.
Well, again, I would say that depends entirely on what the wall's made of.
That is true. Some walls can be more absorbent of impact than other ones. So yeah.
But the bottom line, regardless of what we're talking about here, it is very clear that NASA obfuscates it and uses one example or another depending on what suits them in the model that they want people to believe. And basically what they've described is their latest thing now is they say, yeah, think about it this way. Think about you sitting on a skateboard and having a bowling ball, and then you sit on the skateboard or an office chair with wheels on it or whatever, and you throw that bowling ball away from you as hard as you can. Well, the bowling ball is going to go flying quite a bit further in one direction than you are going to go in the back direction. You will move backwards a little bit, yes, but not as far as the bowling ball, which has not the same amount of mass, is going to go in one direction. Right? So they're trying to say that all this propulsion is simply throwing off more mass than you're propelling. Well, that's flat out impossible. You cannot carry, you have to remember that the rockets have to carry all that mass, not only to offset the inertia that is holding them in place, but then to be able to accelerate them as well. And that can't happen. Because you can't, in other words, you could never carry 1,000 bowling balls and expect to get anywhere throwing them off one at a time because, no matter how fast you throw them off, because as you accelerate, you still have to carry the mass of all those bowling balls with you, right? It's never relieved. It only gets to be more and more and more, right? So, yeah, it's a problem. It really is. And they will never be able to make that definition stick. It just doesn't make any sense. So, all right, cool. So I guess what I want to do now is Zack, and he came out with a new video this week. And I don't know, Zack, if we should play the first one first and kind of explain what we're talking about on that one, since Kyle has never seen this, and then world premiere the second one. How do you want to do this? Or do you want to talk it through, or how do you want to do it?
You could do that. You could play the first one, I guess. I know everybody who's watching may have seen it, but yeah, it takes a few times to watch for it to sink in for quite a few people, so I don't think it would hurt.
Okay, yeah, because this really is important. And guys, This is the thing that, Zach and I have come up with that basically explains what it is that is producing a downward force on things. Now, there are people out there that insist that this downward force does not exist. They insist that density, buoyancy, and equilibrium is all that it takes, and I assure you that is absolutely incorrect. Without that initial downward or initial start of pressure mediation. Remember, Ken Wheeler talks about everything being pressure mediation in the universe, and that is absolutely correct. And it all starts with, the thing that starts that juggernaut is the consistent downward acceleration of things. Remember, there is no other direction that actually causes objects to accelerate other than down. If you watch bubbles going up, they don't accelerate. Sure, they accelerate a little bit, and then they equalize out, and they at a relatively low speed, and until they reach an equilibrium point, and then that's it. But
that is good. That's a good point right there. Kind of comparing the speed of a bubble rising compared to something falling. That's right. An awesome observation right there.
Yeah, and one of the big things that we had, and we have several examples of it, but things falling in vacuum chambers, but a lot of people don't like the Felix Baumgartner demonstration or not. I tend to believe that it's absolutely real, and the reason for this is because we saw those same kind of acceleration speeds of the balloons when they drop down, how fast they drop down. These things can get above supersonic speed, right, while they're accelerating. Well, how is that possible? Right? How is it that only in the down direction do things go so fast that they can actually break into supersonic speed, and nothing else causes that to happen until it gets down into the 50, 40, 30,000 foot range, in which case you are now starting to get enough viscosity in the atmosphere where it starts slowing it down to where you get this effect called terminal velocity, which means that objects slow down to about 120 miles an hour, give or take. And they stay there until, you pop your parachute and you land, right? No other direction does this. And the reason for that is because when you go up that high, you are getting away from all of the matter, all of the atmosphere, right, up at the top, which means that there is something that's pulling all the atmosphere down too. We know this has to be the case. And we also know that being in a flat earth, that we have to be in an enclosed system, right? And knowing that we're in an enclosed system, that explains very well for us, not so well for the ball earther, but it explains very well for us the way that we can have a gradiated gas pressure starting at 14.7 psi at sea level, and getting less and less and less as it goes up, to the point theoretically where it becomes almost nothing. Well, that couldn't happen if it really went into these negative, torr that they say outer space is at, because no gravity or no force would be able to hold our atmosphere in. It would just get blown off into space. We'd all be dead. Say goodnight. That's it. So we know we are in a construct. There is no doubt about it, right? The other thing that we know about this construct is that there is an electrostatic gradient of 100 volts per meter that has been measured and verified by Richard Feynman and many other physics institutions.
Starting when he did the kite, or he didn't do the kite. He did the drone and sent up the electrode. He sent the electrode up with the drone and got a charge from the ground just out of the air, right?
Yeah, you're talking about this right here. Let's go ahead and play this really quick.
Hi gang! I'd previously demonstrated generating power using atmospheric electricity. A hexacopter was used to lift one end of a wire high up into the air. Meanwhile, the other end of the wire was connected to a corona motor near the ground. Electricity then flowed through the wire and corona motor, making it turn. In this video, I'm going to explain how it works. Much of the following explanation is adapted from Nobel Prize winning physicist Richard Feynman's lecture on physics, a section called Electricity in the Atmosphere. For every meter you go up in the air, the voltage increases by around 100 volts, or we could say around 100 volts per yard. We can draw these voltage increases using what are called equipotential lines. Notice that the ground is negative and the sky is positive with respect to each other. According to Feynman, this extends upward to 50 kilometers, or 31 miles, where the air is very conductive. This is the case in fair weather. In stormy weather, like a thunderstorm, things are quite different, and I won't talk about that here. But if this voltage exists between your head and the ground, why don't you get a shock? The reason is that your body is a good enough electrical conductor that standing on the ground, you're basically a part of the ground. The equipotential lines would look like this. There's still effectively 0 volts between the top of your head and ground. Similar effects happen with trees, buildings, and so on. What about the electric current? A downward electrical current exists and consists of positive ions, molecules or clumps of matter that have a positive charge. These ions are moving slowly toward the ground. The current density from these ions is very small, around 10 microamps or 10 picoamps, crossing each square meter or yard every second. So in any small area, there's not a lot of power. And that's the explanation about it.
Whoa, okay.
Okay.
I'm just thinking about the whole the thing that the astro particles that they're claiming are that they're using to X-ray the pyramids with, and I'm just I look at this and I can't help but think of that.
I know. Yeah, you can go a lot of places with this, believe me. But the point is the last thing that they showed there is very much at the heart of this argument. One thing that we can say about all matter known in the universe, all matter, without exception whatsoever, is that it has a charge potential, whether it be positive or negative, or positive or less positive, or negative or more negative, however you want to look at it, or whatever, it all has a varying charge potential. We know this because we can affect it by, rubbing a balloon on our hair, and we can draw water, we can draw minerals, we can draw protein matter, we can draw elements, all this stuff. Everything is absolutely affected by electrostatic energy because it is all made from charged particles. All birds of a feather, guys. Now, the crux of this argument is the one thing that the flat Earth model has that the ball Earth model does not is a reasonable explanation as to what is causing that 100 volts per meter equipotential voltage that rises up to at least 50 kilometers, and I'm saying that it goes to 100 kilometers, which is 62 miles. And of course, you've heard me talk about this before. There are so many things that happen at 62 miles, right? Like the ionosphere, for one, where supposedly all of the radio waves are bouncing off of. Sprites and elves, right? Supposedly where we're getting upward discharges of lightning. And the only way you can have an upward discharge or even a downward discharge is to have a large enough static potential difference for there to be a discharge, right? Whether it's up or down, which tells us that the friction of the clouds or whatever is being either drawn up to the bottom layer of the firmament, right? And then it flattens out, forming sprites and elves, and we can see that very clearly, or standard lightning discharge, right? So we're seeing all this. We know for a fact it's there. We also have this mysterious sodium layer, right? That supposedly is where? 62 miles. What happens with that? Well, the sodium layer is something that supposedly is just out there in outer space, right at the beginning of outer space, for no particular reason. We got this sodium layer out there for no reason. And what they are able to do with it is they're able to fire a yellow laser at it, and it will fluoresce this sodium layer and be able to create a low magnitude or a high brightness artificial star. All right. Wow, that's crazy. I thought about that. It's like, why would that be there? What, how in the hell did they ever figure this out in the first place? Well, the reason is because it's crystalline. It is the bottom layer of the firmament. And yes, it's definitely reacting, and lasers will react with crystals. And we can demonstrate that in a myriad of ways. But even beyond that, guys, we have something in basic engineering classes, and any electrical engineer can tell you this. This is 101 stuff, guys, where we deal with what's called a Gaussian surface, okay? And inside of a Gaussian surface, it's basically like a capacitor. You have two plates where you can apply different charges to, and there will, in between those two plates, there will be equidistant and equipotential lines of voltage, that will be divided up equally with whatever distance is between those plates. Okay, well, in this particular case, it is the flat Earth construct itself, the Earth that forms the bottom part of this Gaussian surface, and the firmament that forms the top part, which we know has a combined, at rest static potential of 10 million volts. All right. That's a lot of voltage, guys. That's a lot of voltage. And so
I could move mountains with that much voltage.
Oh, yeah, you absolutely can. And there's no doubt that it's absolutely there, right? So, but in a ball Earth, there is no explanation. In fact, the ball Earth's excuse for it, what they're trying to say is causing it, is that it's being caused by the incoming cosmic rays. Nonsense. That is not what causes it. It would be different at every single orbital position everywhere. It would never be the same. It would never have the consistency of what it has. It would never have all these coincidences that are constantly at 62 miles, right?
There's a heartbeat every day. It beats like a heart. There's a heartbeat, and then there's another heartbeat that happens like every couple seconds.
Exactly.
One.
Yes, and oh man, there's just so much evidence to it, guys. And I've gone into this a million times before, but I could do a 3-hour show on just the evidence for the firmament, and I will do them more because they're there, guys. There's no doubt about it. And the baller, they got nothing. They got nothing, right? But so again, electrical engineering 101, Gaussian surfaces. You have the firmament as one Gaussian surface, you have the Earth as another Gaussian surface, and then you divide it up and you get that 100 volts per meter all over the plane in a beautiful linearity. And also any changes to it take place plane wide, right? All over the plane. Now, if it was a ball and it was coming from different areas of incoming cosmic rays, that couldn't and wouldn't happen. All right. So what's happening then? Well, we now know that we have a closed system. We know that closed system is charged with a super high voltage that gives us these electrical levels that are in our atmosphere, and that is absolutely responsible for everything. And if you remember what this guy was showing back here, this little graphic right here, right, where these things are going down, it is, and Ken Wheeler said this, and believe it or not, I never thought I would agree with Dell from Beyond the Imaginary Curve, but he made a case quite convincingly that things don't pull in the natural world, things push. That pressure mediation is a product of pushing and pushing only, and we can make one hell of a case for that. And this is precisely what is happening here. You have the positive firmament, you have the negative Earth, and you have a downward pressure that is pushing down. This, ladies and gentlemen, is that weak force of what we're calling gravity, and what the heliocentrists are completely obfuscating, because there's no way that could possibly exist, what they're defining as gravity, at all. It requires this. Now, can we replicate this in a lab? Oh, you better believe we can.
This
Not
is
only,
the gravitational waterfall I've been like
This is
visualizing
it.
forever now.
Yeah,
The
well,
gravitational waterfall.
we're gonna lay it out for you.
It's like little particles that,
Yeah.
go like right through you.
Right. We're going to lay it out for you. So yes, we can replicate this in a lab. In fact, we have Zack with his Van de Graaff generator doing just that on multiple different materials. Doesn't matter if it's glass, water, Coke, Pepsi, hair, follicle, cereal. It doesn't matter what it is. Iron. It all works. It all works. And as we have found out most recently, in nature is doing this. When spiders are doing the act of ballooning, right? It was always thought that spiders would cast out silk from their abdomen, and that the winds would catch their silk, and they would just ride those winds all over the place. Well, guess what? University of Bristol did a test where they replicated, and they created their own equipotential setup, right? And made it a closed environment. And then they put the spiders in it, and they found out that the spiders, what they were doing is they would change the electrical charge potential on that silk, which would allow them to go up and down in that electrostatic potential of 100 volts per meter. Absolutely guaranteed. NASA themselves says that they use a technique called electrostatic tethering, right? Where they supposedly, out of the satellites, and we know this is BS, guys, but what they do is they do put it in the balloons, where they put a long conductive material on the outside of the balloons, and then they will put a charge potential to that, which will interact with the electrostatic electropotential that is between the Earth and the firmament, and they can also cause a direct rise or drop just by changing the electrical potential of that tether, right? I can go all day long on this, guys, but what we want to show now is how this applies to this continuous downward accelerative force that only takes place in one direction, and that when you get rid of all kinds of other matter, then the only thing left is that downward thing, and it doesn't matter what it is. Even if it's gas, Nathan Oakley, it will make it go down, go boom boom, and we're going to show that. And I get so sick of you blasting people and telling them how stupid they are for believing this. It's nonsense. You don't know anything about science, Nathan. You know nothing. You really need to keep your mouth shut. All right. So we're going to show you this and show you how it works. And it's really quite simple. It's really quite simple. But for those of you that want to hold on to this idea that density and buoyancy are all that it takes, you are dead wrong. And we're going to prove it to you again right now. All right. So we're going to go back to this video, and this was Zach's first video on this, and there were some things that we omitted in it. It was an oversight, and then he has created a new one which elaborates on it, but we want to kind of explain it and play this video for you. And Zach, again, anybody has any comments, just start talking. And then after this, we will world premiere his video, the latest video that he just did that elaborates on this. And we'll probably call it a show after that. So you guys good with that? Alrighty then, here we go.
Sounds good.
Hello, everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala if you prefer. In this video, we will be explaining how incoherent electrostatic acceleration creates the downward vector. Gravitation, a word which many do not comprehend, is a theory that was created to explain the paths of the luminaries above and what keeps them in orbit around other bodies, including our Earth. It has been known and taught in college-level physics courses that the electric forces that hold the Earth together are 26 times stronger than the gravitational forces that are supposedly here on Earth.
Thank you. Yeah, I messed that up right there too. I should redo both of them together now and just put out a full length one. But it's 10 to the 26 times stronger. So that's a 10 with 26 zeros behind it.
Okay.
That's how many times stronger the electricity is, not just 26 times.
Yeah.
It's way bigger than that.
Exactly. And that would make a lot of sense. And why we required these extremely high voltages to cause this downward acceleration. But yeah, whatever. What's a few zeros, right? Hey, Michio Kaku admits to being 10 to the 120th off. You're closer than that, right? All right,
Yeah.
let's continue on.
Fair enough.
I will now show you a short video of former MIT physics professor Walter Lewin explain this quite clearly.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass. The Earth and Mars have each a charge of about 400,000 coulombs. The gravitational force between them is therefore about 17 orders of magnitude larger than the electric force.
So even though our immediate surroundings are dominated by electric forces, including your own body for that matter, the behavior of the universe on a large scale is dictated by gravity.
As you heard the professor state, gravity does not take place until we start talking about a moon orbiting a planet, the planet orbiting a sun, or stars orbiting the center of their galaxies. I fully agree that this is a theoretical concept that is unproven still today, and find it odd that they need ideas such as dark matter to make up over 90% of their model to explain how it is possible. Having said this, I completely understand people's reluctancy to use gravity in any kind of discussion about the place we live. At the same time, most people who have never been educated on the subject correctly believe that the force holding things in orbit and the force making things fall are one and the same, in which lies the problem. It is hard to explain how this place works when most do not know how the laws of electricity control the world around us. I will try in this video to explain how incoherent electrostatic acceleration works while using examples that can be recreated by anyone. To start out, we will take a look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces. A Gaussian surface is simply a surface that encloses or distributes a charge. If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomenon will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction. Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated, or polarized, due to the electrostatic charge of its surrounding area. If one set of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth, the positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered a vector. The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above.
And by the way, guys, this is an outstanding visual for this. The downward pressure, and you kind of have the drain or the return, the ground return of this force, pushing things down. And like I said, I never thought I'd agree with Dell beyond the imaginary curve. Actually, we agree on more stuff than you might imagine. But he was absolutely right about that, especially after I started thinking about it. It is definitely a universe that is based on pressure mediation, and that pressure mediation takes place via a push force. And we'll expand on that too, because that in and of itself is amazing. And Dell actually had some fantastic stuff to say about that. So gotta give credit where credit is due. He nailed it, point blank. And so hats off to you, Dell. And let's continue on.
When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter. You can move wood, iron filings, and even human hair with these forces. Believe it or not, you can even get water to bend. If the vector lines created between the two Gaussian surfaces are curved, all the matter will follow these field lines as well. In this demonstration, instead of using a flat plane, I use two circular objects as my Gaussian surfaces. You can see that as the water settles after being sloshed around by me turning the wheel on the Van de Graaff generator, it comes to rest with a curve in the surface following the electric field lines between the two spheres.
Yep, so all I can say to that, ballers, is eat our dust. It took a flat earther to show you something that you simply were incapable of comprehending or understanding the mechanics of as to how it could even be possible. Your heliocentric model is dead, and a lot of flack. Yeah, bunch of BS. I mean, they just never were even close, and they'll never admit that. Never will they admit that. But yeah, isn't it amazing? It took a flat earther to demonstrate this. But yeah, and it gets better, guys. Let's continue on.
This is why the ionosphere, a phenomenon that has never been created in a lab, is a theory yet to be verified, but is needed to create this phenomenon here on Earth. Maxwell himself changed Ampere's law, which stated plainly that without matter, no electrostatic field can exist. Maxwell changed it with no scientific evidence, allowing it to gather magically above our heads in free space. Density and electric potential go hand in hand. The denser something is, the more electric potential it can hold. Not that I believe in the model of the atom, but even the periodic table has a distinction on the amount of electric potential there is in the different elements. In this demonstration, I have a metal button hanging from helium balloons that keep the button buoyant just above the ground. By only adding more electrostatic potential to the button, you can see it will appear heavier and force the buoyant object down along the vector lines created by the electrostatic potential difference. Without changing the density of the medium or the object, one can change the overall weight, or gravitas, of the object. To do an actual experiment on the topic of gravitation, this variable of electrostatic acceleration must be taken into account at all times. Now we will take a look at how different electric potentials of gases act in this electrostatic medium we live in. Gases have different electric potentials, just like all matter does. The gas molecules that can hold more potential than those gas molecules around them are theoretically more dense and will have a stronger attraction towards the negative ground below. When these gases are carried along the downward vector by these electrostatic forces, the lighter gas gets displaced and becomes buoyant until it finds a place with the same electrostatic potential. This is why we have...
All right, one other thing I want to mention is that if you look at a periodic table of elements, guys, it's interesting to note that the number that accommodates hydrogen being number 1, helium number 2, goes up in commensurate with the density of the particular element. This is precisely why you have hydrogen and helium and other noble gases which have a far less responsive influence by the downward vector as compared to everything else. But like I said, when you remove all the particulate matter or create a vacuum, so to speak, or at least as perfect as we can get one, 10 to the negative 6 torr or whatever, which is thousands, millions of times less than, what you might imagine. And that's something else we're going to do another expose on, is that. But yeah, it's very interesting to see that that periodic table of elements goes right along with the behavior of these elements in this downward vector field. That's not a coincidence, guys. That is reality. And it's undebunkable. It's a fact. Let's continue.
Have a pressure density gradient and are told the noble gases work their way up into the higher elevations and collect in layers above. This has not been verified by anyone I know, so at this point I cannot say if this is true or not. Through this induction, some pretty amazing things happen when large electric potential differences are applied to gases. When gases are placed into an area with a strong electric potential difference, we get the phenomenon known as ionic wind. If a person were to charge themselves up with 1 million volts of static electricity, they could blow out a candle almost 2 feet away from the gases rushing away from their fingertip because of the exceptional potential difference. We do know that when a gas loses its electric potential, it slows down so much that it turns into a liquid, like the condensation that forms on a window when it's cold outside. The gases hit the cold window and transfer their potential energy to it, trying to mediate the temperature. In doing so, the gases lose their electric potential and turn into a liquid. Down here near the surface, the system is very dynamic, with all the plants and animals breathing, low altitude weather patterns constantly cycling, and Earth releasing gases from the deep at all times.
Now, one thing I'm going to say, guys, is this behavior that Zack is talking about here is in stark contrast to what they call the ideal gas law, right? Now, the ideal gas law is where some people in this community get the notion that gas molecules will forever be in motion and will never have a change of state. They will just, ad infinitum, be in motion all the time, forever and ever and ever. And that is part of what they call the ideal gas law. Well, the problem with that is it is well known and openly admitted by mainstream physics that the only reason that the concept of the ideal gas law is even brought into this discussion is because they cannot solve any of these equations mathematically without it. In other words, they have to lock it to a state which it can never be in, and they have to say that this is the way that it's behaving, which it never can do, to be able to prove their theories mathematically, which is patently absurd. Some people in this community have mistaken this ideal gas law for the notion that you can forever and ever have perpetual motion, and gases will constantly expand in all directions forever and ever and ever. And the reality is it's not true. It is simply not true, period. Mainstream physics admits it. Our experimental evidence proves it. And it is nothing more than another mathematical construct that they have used as a crutch, and that some people have just so mistakenly, gone to attack other flat earthers on, and, show their own ignorance on, basically. And you come up with this idea of, gas doesn't go down, go boom, boom. It most certainly does. And if you put gas, even hydrogen, the lightest gas we have, if you put that into a vacuum, the hydrogen is going to sit on the bottom of that vacuum chamber. And we're going to prove that. Why? Because we can prove it with many other gases. And we're going to show you that. We're going to show it to you with carbon dioxide. We're going to show it to you with sulfur hex, and several other gases. And, these guys are making this blanket statement that all gases do this. That's nonsense. And it's a lie. And it's not true. And it comes from a, dare I say, a grocery delivery boy understanding of physics, which is absurd. Okay? Don't listen to it. Don't buy it. These people have no idea what they're talking about. And that's all I'm going to say about it. But, the thing that irks me about it, guys, is anybody that tries to even discuss this is attacked viciously. And I have a problem with that. And you should too. This is supposed to be an open discussion where we can discuss things calmly, not only with ball earthers, but especially with other flat earthers. And we don't need this kind of horse crap, rivalry going on, as a matter of ego. It's just nonsense to do this. So I'm just saying, use your mind, people. Understand what we're saying. We're going to give you all the proof. We've already given you all the proof, and we're going to give you more proof constantly, because like I said, even mainstream physics agrees with us, and we're going to have some very choice quotes to prove it. Okay, let's continue.
Times. We will never see all the gases lose their potential and turn into a liquid anytime soon, I hope. Now we will get to the incoherent part of the phrase. It is called incoherent because it is not completely polarized, like a magnet, but only slightly on its surface through electrostatic induction. A magnet, with all of its potential stored on opposite sides, would be considered coherent. Now these forces are very weak, and only apply a slight pressure along the vector they create. All other pressure mediations, such as buoyancy, atmospheric pressure, and temperature, are certainly stronger. But nonetheless, these weak electrostatic forces are ever present in the world around us, and I fear the day they may come to an end. Again, I fully understand people's reluctancy to use the word gravity when speaking of this place we live. So instead, let's call it what it really is: incoherent electrostatic acceleration. Let's teach those just finding out the nature of this world in which we live the correct way. The fact that we live in an electric realm, with a static electric field you yourself can go out and measure, tells us without a doubt that these well-understood laws of electricity create the downward bias phenomena we witness all across the plane. Instead of using the word gravitation, I ask you to educate yourself further on incoherent electrostatic acceleration. This is Good Times for All here, signing out. As always, thanks for watching.
Nice video, nice job, Zack. Really nice.
Very nice video, Zack. Absolutely. So
Amazing, yeah.
So now we have the part 2, which we're going to, talk about here. And then we're going to add on, some of the additional evidence that I talked about before. But guys, like I said, there are definite variances in these downward forces, right? And as much as people don't want to believe in things like gravimeters, all they're doing is using like laser interferometry technology to measure different acceleration rates of masses around the plane. Why would there be different acceleration masses around the plane? Well, primarily because depending on what is in the atmosphere and also above and in between the Gaussian plates is going to change the potential, on a somewhat of a basis over these areas, right? So for whatever reason, they want to tell you that it will give you a better idea of what's going on as far as the masses that are making up the Earth. And to some degree, there is truth to that. But, what it really does is it shows us variances in that downward electrostatic force. And that's what gravimeters do. It really has nothing to do with gravity. Gravimeters have nothing to do with gravity. Gravimeters have everything to do with the downward electrostatic vector that we are talking about here that accelerates things in one direction only, and that's down, unless you're, of course, a ball earther, in which case then up is down and down is up, and there is no absolute direction. Everything is relative. Of course, we know that's nonsense. So
I wonder
now,
if you measure it during the pulse of the electrostatic field, the Schumann resonance.
I
wonder if there would be a different rate of acceleration. It's a very slim amount of force or acceleration, but I wonder if there's a difference because the electric field changes. It pulses like that and gets a little bit stronger. I don't know.
Well, it's something that we can test, and we actually have other tests that we still have the magnets, which I believe the two opposing pole force magnets that you've created the balls for are going to fall at different rates. We had the Lockheed engineer that insisted, after umpteen dozen, tries that he did it with, it absolutely was true. We've created that. Ken Wheeler has created that and has showed in his videos. He goes, I wish you could feel this. And Zack and I wish you guys could feel it too, because it's amazing when you do that and you kind of let the ball apparatus with the two opposing magnets drop and fall in your hand, you can feel a resistance, right, to this downward acceleration. It's freaking bizarre, right? But I assure you it's real. Zack's felt it. I felt it. Cami's felt it. Ken Wheeler talks about it. We have Lockheed engineers that did the original tests on it. We've been sitting at a stalemate for over a year on trying to get it done because we're having such a hard time finding a place to do this experiment. But we have,
and I've noticed real muscular people have a lot of trouble feeling it.
Really?
Yeah, because remember I took them to Flattoberfest, and I'll take them to this Flattoberfest too. I'd like to kind of test my theory out. But yeah, it has to do with, because it's such a slight difference. And people that are a lot stronger, they pick up a 5-pound weight, it weighs real light to them. Other people pick it up, it feels a lot heavier. So maybe they don't have that finesse, that touch of little tiny increments amounts of weight. I don't know. But yeah, a lot of I didn't notice until like the second day. But I noticed when I would hand it to somebody that was like a steel worker or somebody like that, a big guy, he was like, nope, I don't feel anything. But
Yeah,
then
that
a
is
lot of
weird.
other people that weren't, big and muscular like that, they could feel it.
Yep. And we do also have other tests. There's that really, really brief clip where it shows this little container that shows like, 10 different elements that are flipped up, and then they run it in super slow-mo, and each element actually hits the ground at different, it's in a vacuum, it's all in a vacuum, and each element actually hits the bottom of the container at a little bit different times. So we also have that as evidence. So the statement that NASA patently feeds us, which again is nonsense, is that feathers and bowling balls and everything else falls at exactly the same rate, is absolutely not true. And their own gravimeters prove that. But for them, it's a matter of telling what the Earth is made of, because they're trying to fit this whole paradigm into the mass attracts mass, and the more mass you have, the more attractive it's going to be to other mass. Well, sorry, but experimentally, it doesn't pan out. This does. So ladies and gentlemen, this is the new video, which we are world premiering right now. Zack's new video, which elaborates on what we're talking about. And Zack, anything you want to say before we fire it up?
Nope. I just think it was great that we played the first one for Kyle, because without that one, he wouldn't have even got the gist. That was like the main part of it right there. And then this one kind of adds on to it.
Yeah. And
I appreciate that.
And honestly, I kind of want to get rid of the, where Walter Lewin is saying, yeah, it's, even though he's right, where he says, well, we're applying this out in the cosmos. Yeah, he says that, and they tell us that, but it's really not true, because we don't know what's going on out in the quote unquote cosmos. Okay.
Yeah, maybe I'll add Michio Kaku after that, saying how they're off by one with 120 zeros after it.
Right, 10 to the 120th, exactly. Yeah. And that of course is something that I explained a long time ago, that, my explanation for why Michio Kaku says that the modern cosmology is off by a factor of 10 to the 120th is because that sounds about right. When you look at our little bitty dome construct here, which is very, very small in comparison to what NASA and the mainstream wants us to believe is out there, right? There is a huge mismatch. And that's why they have to continually make up pseudo forces and misdefine mass and all these things that they do to contradict themselves, because it's all a matter of changing the story on the fly and applying it, where it's going to do them the most good for their own credibility. But NASA, you've been busted. It's over. Say goodnight. Okay, here we go. Let's watch this video.
There in YouTube land. This is good times for all, or Zachary Zabala if you prefer. In this video, we'll be taking a deeper look into incoherent electrostatic acceleration, and we'll be calling this part 2. I was happy to see so many grasp the concepts of the laws of electricity, but still see some having issues connecting all the pieces together. I am fully to blame, as I realized I did not touch on the subject of acceleration at all, and for this I apologize. It was an oversight we will try to remedy in this video. If you haven't seen the first video, I recommend watching it first, before continuing along here. The link is in the description below. First off, if you didn't notice from the first video, gravity does not affect anything down here on Earth, and is only trying to explain the path of the luminaries above, i.e., the sun, moon, stars, and solar systems in the heliocentric model of our universe. I will once again show former physics professor of MIT for 4 decades, Dr. Walter Lewin, explain this in simple terms.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together. And now you may say, that's very inconsistent with what you just told us, because didn't you tell us that D cancels if you compare gravity with electricity?
Yes, but keep in mind that most objects in the universe have only a very small amount of charge per unit mass. The Earth and Mars
have each a charge of about 400,000 coulombs. The gravitational force between them is therefore about 17 orders of magnitude larger than the electric force. So even though our...
And by the way, guys, I just want to say his statement there, where he says the Earth and Mars, or Marth, he kind of pronounces it weird.
The Earth.
And
he
Marth.
pronounced like Carl Sagan.
Yeah, exactly.
Yeah, it just remind me that.
Is about 400,000 coulombs. Well, first of all, that's horse hockey. We have no way of telling what Mars's, static potential is, and nor do we really know what it is on Earth, right? Especially in the heliocentric model. I have no idea where they, what orifice they pulled that out of, but since nobody can ever verify it, that we'll never be able to tell. But one thing I can say is that with the electrostatic voltages that we can measure and show in equipotential lines of 10 million volts, it's likely much, much higher than that, right? But I don't know, can't measure it. But just wanted to say that because, Walter's doing his job. He's out there, preaching the mainstream rhetoric, but there is no way that we know or we can verify what he's saying is true. There's just no way. Let's continue.
Yep. Our immediate surroundings are dominated by electric forces, including your own body, for that matter. The behavior of the universe on a large scale is dictated by gravity.
As you heard, the professor state quite plainly it is electricity that holds our world together.
On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together.
See? Then he stated that not until referring to moons, planets, and stars does gravity take effect.
But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together.
Any physicist worth their weight in salt knows that the electric forces here on Earth are 1,000,000,000,000,000,000,000,000,000. You know what? I lost count. Too many zeros. So we just say 10 to the 26th power. Anyone arguing about Newtonian or Einsteinian types of gravity are only speaking about the lights in the sky, or are over 150 years out of date, as this was well understood when Maxwell wrote his equations. This was the reason the ionosphere was created over 100 years ago, with no test to show it even possible to occur, how they claim. It is clear that many of us who were not educated much further than high school in physics were never taught this at all, and makes me wonder why they would tell anyone gravity holds them to the Earth. That was one part of the first video that some had overlooked and I thought was crucial to see. This is taught in the mainstream, high education curriculum, and is not something new we are sharing. Now that we have that out of the way, I would like to apologize once more for leaving out the acceleration part of the topic, as it is one of the most important parts to help us comprehend that there is a vector or downward bias here on Earth. Remember, a vector is an indicator showing what direction matter will go depending on the surrounding electrostatic field compared to its own electrostatic charge, and at what potential it will travel. Here on Earth, we have an electrostatic gradient in the atmosphere that rises in potential the further you get from the surface. The potential grows 100 volts every meter linearly as you rise from the plane, which indicates we are between two Gaussian surfaces. This you may remember from the first video, but what I left out was that only in one direction do things accelerate. Comprehending this is key to seeing the bias in direction.
Hey guys, I got to tell you, many of you may remember this original discussion that took place over a year ago between Morgile, Iru, Jeran, and me when I was trying to guide them through a hypothetical discussion on gravity, right? And I'll never forget it because, man, did I catch a lot of flack from my own teammates. And, they just were not, they were having none of it. They were having absolutely none of it. I do think that everybody's come a ways since then. I do know that the thing that brought Jeran over finally was the realization of the acceleration. That's something that you cannot simply explain by saying, oh, that's just the way it is, or that's explained by density and buoyancy. No, it is not. There has to be, again, like I said, when there's an acceleration, every law of physics that applies to every other acceleration that we are aware of is caused by some sort of a force. And whether or not you want to define gravity or whatever as a force, that's up to you. But one thing I can tell you for a fact is that electrostatic potential is a force. It is absolutely a force. It's a force that can be devastating or life-saving, but it's absolutely a force, and it's absolutely real. And and the thing, like I said, the thing that swung Jeran over finally was the realization that, hey, things are accelerating, guys. They're accelerating when they go down. Nothing else can claim that, and nothing else can explain that. So just wanted to point that out.
This next picture is great. If you could just go forward a couple seconds and pause it on that picture of the girl dropping it, that's a great explanation of the acceleration. At 1 second, it's dropping 9.8 meters, but at 2 seconds, it's dropping 19.6. 3, 29.4. It's picking up speed. That's the only direction that acceleration will keep continuing to happen like that.
That's right. That's right. No other direction, which should tell you something, people. Things don't just do that. You cannot willy-nilly explain it away like, well, God made it that way. Well, even if God made it that way, he made it that way using his engineering or his divine providence or whatever, but he made it that way. Therefore, there must be a background story to it or some background effect to it. Well, this is it. And it takes the place of in electricity. And isn't it interesting that electricity also contains the prefix of L? L is another name for God, right? You cannot deny this, guys. So this is a perfect melding of religion and science. And, you got to be really careful who you listen to and what you throw out, based on nonsense evidence and real evidence. And this is something that is, guys, you've got to pay attention to this. So Zach, you said play this for a minute and then stop, or just tell me when to stop it.
The only direction that matter accelerates naturally and with no outside force may
the picture right there, the free fall acceleration. Yeah.
Okay. Yeah. And that shows exactly what it is. So yeah, this 9.8 meters per second squared. And this goes back to Kyle's question, right? What's happening with the ISS, right? If we are going around the Earth at 17,500 miles per hour, what has happened there to stop the ISS from needing to accelerate even more, right? Because if we're constantly falling and we're falling at an exponential rate and it's going up like this, then why is it that that when the ISS hits 17,500 miles per hour or 5 miles per second, that we don't have to fall down any faster than to match that 17,500 mile an hour forward velocity, right? That doesn't add up. That doesn't make any sense. If it's going 17,500 miles an hour forward, the only way to offset that and remain in a stable orbit is if it is also going down at a speed of 17,500 miles per hour. Why did it stop? Right? Well, it stopped because NASA just said, well, we better stop it there because we can't, pretty soon you'd have to say that it's going the speed of light. And that's never going to happen, right? That's never going to happen. So what do? How do they deal with it? They ignore it. They ignore it and then call anybody that questions it stupid and ignorant and everything like that, guys. Again, Kyle was 100% right in questioning that. I questioned that at the same time. The whole 9 yards about the gyro stabilizers on the ISS is a joke, because those things would have to be massive. They'd have to be mammoth to be able to overtake the mass of the ISS and twist it literally around the Earth to keep the bottom of the cupola facing towards the Earth at all times. And isn't it amazing that you would think that we would have a picture from the ISS that would always be right out at the front edge of the Earth, but that isn't the case. We seem to be, always at that one perspective that shows it always on top, and it's always everything in front of it. Nothing about it makes any sense, guys. It's just nonsense. So again, common sense. NASA will never, and no Glober will ever be able to explain this. I dare you to come up with an explanation, and I dare you even more to come up with a demonstrable explanation that outdoes this one. You're never going to be able to do it. So let's continue.
Made by an animal, plant, or mineral is toward the Gaussian surface with less potential, better known as Earth. This acceleration is very weak at small distances, yet can be very destructive at large ones. The distance we are concentrating on is a vertical one, along the vector created by the Earth's electric field. Imagine dropping a bowling ball onto a couch from around 6 inches. It would make an indentation into the cushion, coming to rest in the center, and the couch would be in good working order after you lifted it off. Now we will drop the ball from around 10 feet up. And instead of the ball remaining on the cushion, it might now bounce off due to the potential it had when it made contact with the couch, causing a much larger reaction of the cushion and springs beneath. It gained this potential because it traveled longer along the vector line that caused it to accelerate. Last, we will drop it from an airplane. Not that I have tested it, but I doubt the couch would be much use as a furniture piece after the bowling ball came to rest, wherever that may be. Probably a few floors below the couch, I would bet. Now someone might claim a helium balloon does not succumb to these accelerations. But if you remember in the first video, this acceleration is very weak, and potential differences of other phenomena such as temperature, gas pressure, and buoyancy are much stronger. If one places a helium balloon in a vacuum chamber where it is more dense than the surrounding area, it most certainly shows it is affected by the downward bias. Outside the chamber, the balloon will rise, but not at an accelerated rate. The same with air bubbles underwater released by a diver. They do not accelerate up but are displaced by the water, which is more dense and therefore the matter in the area most affected by the downward bias. It doesn't keep accelerating up because the water around it only needs to travel the distance of the bubble before the potential is equalized again. The process is then again repeated with the water just above the bubble until it reaches the surface and there is no more water to displace it. Last off, I have heard some state the ideal gas laws disprove electrostatic acceleration on gases, and I must admit it makes me chuckle a bit. Here's a high school teacher explaining why they have to do this and that it is a make-believe place.
There are an uncountable number of molecules inside this balloon. It's my breath. But whatever the gases are inside of here, guys, this is absolutely chaotic. It defies study because it's so complicated. You get the idea? So guys, the question is, how do we fix this? And the answer is, we go to the land of make-believe. And guys, this is not stupid and this is not dumbed down. This is smart science. If you've got a system that's so complicated that you can't study it, what do? You simplify the system. And guys, that's what ideal gases are. Ideal gases are simplified gases that make our lives easier. Now guys, be clear. Do ideal gases really exist? No, but we treat them as if they exist. And what allows this to be the case? Don't write this down.
Okay, so isn't it ironic, right, that the flat earthers that are pushing for this, they're always talking about, oh yeah, this happens in Narnia, this happens in Narnia, and you know, they want to talk about gas not going down, go boom boom. You've just heard it from high school, from physics teachers. I can bring up a dozen different physics instructors online that say the exact same thing. Where are they getting it from? Narnia, right? So the very group of flat earthers that claim that you shouldn't get things from Narnia are going directly to Narnia. Why? Because they simply cannot admit they are wrong. And that is ridiculous. That's the problem I have with these people. And, you know, it's up to you. I'm not going to try and convince anybody else. You know, if you can't see how obvious this is, then, you know, whatever. But it's pretty obvious that mainstream knows what happens. Eventually, those gases will run out of those kinetic energies. They will change state. If you don't add pressure and you don't add heat, you're never going to keep up this perpetual motion of gases. It's not going to happen. All right. And we're going to show you several examples of gases that are going down, going boom boom, from carbon dioxide to SF6, and all gases do it, all the way to helium, all the way to hydrogen. And to deny that is the pinnacle of stupidity and ego. Okay, let's finish this video out.
Yeah, that was just the beginning of that lecture. The whole lecture goes really in depth. It's a really good one. And it's just, this is what you're taught in high school physics. This isn't even like the stuff they teach you once you actually pay for it. This is the free stuff they tell us, you know, about these laws and whatnot. The ideal gas law it's make-believe because it has to be, right? It's like the globe. They can't figure out, you know, everything that's going on in the air in a cubic foot in front of your face. It's too dynamic, way too dynamic. So they simplify it a lot.
That's right. So gases not going down, going boom, boom, is an assertion straight from Narnia. Shame on you. Let's continue.
I hope this may have cleared up any misconceptions you may have had on the matter, or at least help further your comprehension of this phenomenon. If you have made it this far and still haven't seen the first video, please click the link below and watch part 1 before asking any questions in the comments below. This is Good Times for All here, signing out. As always, thanks for watching.
All right, very cool. Now, I just want to show you these really quick videos. They're just a few seconds each. And I think that they should probably get across this. Let me see. That's not it. Hang on a second. That's one of them. That's another one. And this is that one. Okay, so here, guys, is a demonstration of sulfur hexafluoride gas not going up in all different directions, but in fact going down in an open container. This is undeniable. You can't deny this. You're seeing it. It's a fact. Watch what happens.
All right, so here's what's happening. There's a gas inside this tank. It's called sulfur hexafluoride. It's a super heavy gas. Sulfur hexafluoride. It's boring. It's inert.
And the fact that it's a super heavy gas is irrelevant. It's a gas. It behaves the same way as helium would or hydrogen would in comparison to the medium that it's in. And when you put helium inside of a vacuum, helium will lay down the same exact way. Why? Because you do not have that ideal gas reality, because it's not a reality, to continuously stimulate it into perpetual motion. That's why. So let's continue.
It's odorless. Okay, so it's normally boring, but here, watch this. I'm going to slowly pull the lid off.
Okay.
So that should be perfect. Gary, would you take that little end off over there as well? You see that used? Yeah.
Yes,
All right,
indeed.
so let's see if, it feels pretty good. So let's see if we can float the boat. Okay? Ready? So here we go. Let's see if we can float the boat. Stay there, little guy. Tell me that's not awesome. Isn't that amazing?
Cool.
And
That
this
is
close to
awesome.
magic.
That gas look like it's going in all directions to you folks? Of course not. It's not. It's staying down. It's going down. It's staying down because there is a density difference and there is a downward vector that is holding it down. Like I said, in a gas chamber, hydrogen will act exactly the same way.
Doesn't conduct electricity. So here's a taser.
Okay.
So all right. So look. So here's the taser. So when I put the taser down inside here, watch this. When I put it down inside, it stops.
Oh, it stops working.
And then when I bring it back out again, so they will keep it. So if you don't want something for arcing from one place to
Doesn't
another,
conduct
but the coolest
electricity.
thing is this:
Right.
because it's inert, you can breathe it, and you might see something different. Ready? So
Can
come
I
here.
go first?
So you just stick your head way down inside and breathe in. Breathe in. Ready? Now talk to the nice people. Try it. Come here. Get in there.
Awesome.
Okay, so enough silliness on that. So basically, that's point one. Point two, here's another one. This is done with a gas called carbon dioxide. And I believe that when our not so learned opponents on our other channel that preach against this were confronted with this, the response was, oh, well, carbon dioxide is not a natural gas. Oh my God. To even make that statement is so ignorant it's beyond belief. Let's see what carbon dioxide gas does to fire and what direction it inherently wants to go. This is baking soda and vinegar, guys. This is a really simple way to make carbon dioxide. Elementary school physics here. Bam, 2 down, 1 to go. Let's look at this one. This one's really short.
That's cool. Way cool.
So somehow me sees gas going down, going boom boom, and people advocating that this doesn't happen have,
Bob.
they picked the wrong day to stop smoking crack. That's all I can say.
And it falls a lot further than that little distance. I've seen people put it up on get up on a ladder and build a little chute and then put the candle at the bottom, and the gas goes all the way down to the bottom of the chute, and like it's rolling down the little trough that they made.
Absolutely. That's right. Because again, to have any type of displacement of anything, there must be physical matter there. Well, no matter what it is, whether it's plasma, matter, gas, solid, whatever, it must be there. And if it's not there, then the most dominant or lowest number on the atomic chart, aka hydrogen, is going to come out on top, pardon the pun. Okay? Don't know how much plainer I can make it, guys, and hopefully this stupidity will stop and the attacks on flat earthers that are trying to understand this will stop. Get with the program, guys. Seriously, it really irks me. All right, that's all I have to say on this, guys. And I think we're going to wrap it up. Hopefully we have gotten our message across here. There's something definitely different going on. Like I said, we can demonstrate this downward force all day long. We have the conditions. We have the known scientific measurable facts that prove the Gaussian surfaces and what happens in between them. This is basic electrical engineering. Guys, I think we have a very solid model here. And I don't give a crap if mainstream doesn't accept it, because of course they're not going to accept anything that invalidates the heliocentric model. That's why they have never acknowledged an electrical universe in the first place. Even the plethora of physicists and scientists and engineers over at the Electric Universe Project who are saying, my good God, it's an electrical universe. Can you not see that? NASA and the mainstream will never agree with that, because it just takes them one step closer to the death of their fantasy. And, it's dead. It's over. And, don't let people keep drawing you into this with stupid ideal gas laws that are being misinterpreted and that have no training in science whatsoever and that have no idea what they're talking about. Okay. So that's all I have, guys. Iro, do you have anything that you want to say about this that you may have learned or may not have learned today?
He had to go.
Oh, did he have to go? Oh, crap. Okay. Oh, man. Yeah, I know. He usually has to be out right away. Okay. Well, Kyle, we'll kick it over to you then as our newest Globebuster.
Okay. Yeah, I just thought it was amazing. It was cool stuff. I learned a lot, and yeah, it really opened my mind to a lot of things, and dare to disagree. That's all I can say. That's what we're all about, right? We don't go into indoctrination by any means. And the moment you start bashing on people who dare to disagree, that's when problems arise, as you were talking about, So we don't want, I'm just trying to say that people shouldn't be demeaning as they're saying, you're trying to tell the mainstream media there that, they're wrong, and they're trying to tell you you're wrong, but it's okay to disagree. That's all I can say is it's okay to disagree.
That's right. It absolutely is okay to disagree, but it's not okay to attack others based on this and, get crude and ask them how their nuts taste and stuff like, my God.
Yes, that's terrible.
Are we decent human beings? We need to
go beyond that.
Or are we animals?
Raise the bar.
Yeah, raise the bar. Yeah. Absolutely. And some people in this community are absolutely juvenile in their behavior, and it makes me sick. It really does.
Yeah. And that's where, if they abuse the privilege of being able to speak to you, they don't deserve it.
Exactly. So yeah, and Kyle and I appear to have somewhat of a disagreement. I don't think it's anything overwhelming. I think basically it's the way that we're looking at things, and I think that we can iron it out. And if Kyle and I can iron it out and work through this with you guys as witness, then you can see how it should be done. Okay.
Yeah.
And I think that this is the example.
We're not foaming at the mouth over it or anything like that by any means.
Yep. But for people that just sit there and want to, criticize you and ask obscene questions and talk about their perverse sexual things, I don't need that. I don't want that. I want nothing to do with people like that. I'm all about open discussion with other people that are investigating the truth and wanting to get to understand the truth.
What I get a lot of is people who like to just leave really short, shallow comments like, yeah, well, you're wrong. I'm like, all right, that's no attempt to persuade me whatsoever, except for by domineering over me, maybe. But yeah, if you're just saying, yeah, well, you're wrong, that's just you stomping your foot on the floor saying, I refuse to be persuaded by you. That's it.
Yeah, exactly. It's, it's as stupid as the ballers coming over here every other day. You proved the 15 degree per hour rotation. It's like, you're a moron. You have no idea what I proved. And you don't even know what you're talking about. But this is their stupidity, and they put it there for us each and every day to marvel at. And I do marvel at it because, We've given all the data. We are using state-of-the-art technology. We did not detect Earth rotation. Even your god, Einstein, said that there was no way to be able to do that through any optical experiment, even though I have to admit, I wholeheartedly disagree with him. I think he's full of crap. And the only reason he had to say that is because they cannot detect any motion, because there isn't any. Not because they can't, or not because it's too little, or not because any other reason other than there is no motion. That is the reason, okay? But, again, you have to keep track of all the sides of the narratives here, right? So there you have it. Zach, you got anything that you want to say before we call this a show?
I'd just like to say a thank you, one to you, Bob, for all the help with these videos. And another one to Miss Nora Noon. Thank you so much, sweetie, for having that chat the other day about this last video I made. It helped a lot. I tweaked a little things here and there, and yeah, it turned out better. So much appreciated, darling.
Awesome. So cool. Well, there you have it, guys. So we're going to call that a show. And one thing I do want to mention is that I put out a thing when we took Mother's Day off about an exception that I had with a position that Iwaranon was taking with the luminiferous ether. He was nice enough to respond to that, and he clarified his position on it. And I think we're much closer now on our position that we're taking on this. And as far as the rest of it, as far as how it forms into physical form, I still have an exception to what he's saying about that. And this goes back to the whole idea of the luminiferous ether being cymatically stimulated into physical form. Okay? I really believe that that is what's happening. I really believe that this is what the Bible is saying, that when God spoke these things into existence, that what we're really being told here is that there are specific tones and frequencies and choruses and chords, etc., that when vibrated into this medium, literally cause our physical world to become manifest. And as such, there will be physical structures that are resonant, that amplify these energies. Okay? That's what he's saying that he's against. I still disagree with that, but I think we're a lot closer from that. And this is something that I really do invite a discussion with Waranon on this subject. Because, let's face it, guys, the luminiferous ether has this theory, and there's actually several different types of luminiferous ethers. And that's not even counting if you want to call it the quantum field or prana or any of the other dozens of names for it. But there are several different types, and, we're doing our best to break them down and show how they apply. And granted, we don't know all the answers, but one thing we do know is that you don't create stuff out of nothing. There has to be some sort of substance there, right? We know that counter space exists. We know that the opposite of a sphere or a toroid is a hyperboloid, right? A hyperboloid, or something that actually goes through centripetal or counter space, right? So you could kind of look at that as an alternate dimension, if you will. But because of the fact that we have so many things that actually are demonstrable, like magnets, for example, that display this, and we can also model it, believe it or not, guys, in water. And I did this on the show, I don't know, a couple months ago. The Flat Earth Woman, she did a fantastic demonstration on this, where the ether was basically being modeled with water, and it's very akin to fluid dynamics. So again, these are things that we will be covering over and over and over again. We'll explain to you our take on it. We certainly welcome your take on it. But one thing you will never hear us say is that if you are, so dumb as to not be able to see it our way, that you must like the taste of our balls. That's never going to happen, because that's just disgusting. It's juvenile and it's sick. Okay? So let's keep it pure. Let's keep it in science. And let's keep it real, guys. So with that, that's all I got, guys. And if that's all you have, let's close her down, okay?
All right, I look forward to next time.
All right, awesome, guys. So we'll see you guys probably on Sunday. Until then, be good to each other. Don't lie to each other. Open your mind. There's truth inside.